Hey there, come on in, get comfortable, and maybe pull a blanket up around your shoulders, because where we are headed tonight is somewhere very cold. I am glad you found this. Whatever kind of day you have had, you can set it down now just for a little while. Tonight we're going back to a story that has been frozen in the ice for 800,000 years, patiently waiting for somebody to come and listen. Beneath 2 miles of solid ice lies a secret older than any pyramid, any language, any civilization. Bubbles of ancient air sealed away for 800,000 years prove something almost impossible to believe. 8 separate times this entire planet slid into a deep, silent freeze. And 8 separate times it thawed itself back out again, like clockwork, like something somewhere was keeping time. And to this day no scientist alive can fully explain why. Before we step into the cold together, do me one small favour. If stories like this pull you in, tap that subscribe button, drop a like and maybe pass this along to someone who could use a slow, quiet night tonight. And if you feel like it, leave a comment down below and tell me where in the world you're watching from and what time it is for you right now. I look through every single one, and it might be my favourite part of doing this. Now go ahead and dim the lights if you can. If there is a fan nearby, switch it on low just for that soft steady hum in the background. It fits tonight's story rather well. Get settled in, get comfortable, and let's begin. Picture this. Not with your eyes open, but the way you picture things right before sleep when the mind goes soft and wide and everything feels close enough to touch. There's no real colour here, not much of one anyway. Just endless shades of white and pale blue-grey stretching out toward a horizon that never seems to change no matter how long you look at it. The cold air does not simply touch your skin, it presses into it, and there is a kind of silence here that barely exists anywhere in the modern world anymore. No engines, no distant traffic, no hum of electricity running through unseen wires, just the faint hiss of drifting snow and your own heartbeat suddenly very loud in your own ears. You are standing on a sheet of ice 2 miles thick, not a frozen lake, not a snowy hill, 2 miles straight down of solid ancient ice stacked up winter after winter, century after century, until it became something closer to solid rock than snow. Above you, the sky is a pale, colourless white. Below you, buried under all that weight, are the bones of a world nobody alive has ever seen. Somewhere far beneath your boots, there is a river that has not flowed in 20,000 years, and a forest that has not felt sunlight in just as long. This is not some distant invented planet. This is right here. This is Chicago. This is Boston. This is the quiet countryside outside London and half of Scandinavia, and the wide empty stretches of what will one day be called Canada. If you stood at the southern edge of it, somewhere around what is now Ohio or Illinois, and looked north, you would see nothing but a wall of ice rising up into the clouds, curving away in both directions for as far as you could turn your head. 20,000 years ago, nearly a third of all the dry land on Earth lay buried this way, crushed beneath ice that in places could have swallowed the world's tallest skyscraper whole, with nearly 2 miles of ice still stacked on top of it. And that is only half the story. So much of the planet's water was locked away inside that ice that the ocean itself dropped by close to 400 feet, roughly the height of a 40-story building. Whole coastlines you would recognize today simply did not exist yet. There was dry, walkable ground where the English Channel now sits. There was a wide bridge of frozen earth joining Siberia to Alaska, wide enough that entire generations of people could be born, grow old, and pass on never knowing they were in fact standing on ground that would one day disappear beneath 2 separate oceans. Now follow me a little further south, past the edge of all that ice, to a landscape almost nobody pictures when they think about an ice age. Not endless white. Grass, Miles and miles of pale golden grass rippling under a low cold sun, stretching from what is now France, clear across Siberia, all the way to Alaska. Scientists call it the Mammoth Steppe, and it may have been the single largest connected ecosystem this planet has ever produced, and it is exactly what it sounds like. Somewhere out there right now in our imagination, a herd of woolly mammoths moves slowly across the frozen grassland, their breath rising in thick clouds around long curved tusks. They are covered in fur that can grow past 3 feet in length, with a layer of fat underneath thick enough to make any modern winter coat look a little embarrassed. Their ears are small, tucked in close, because out here, anything that sticks out too far simply freezes. When the grass disappears under a fresh drift of snow, they swing their heads low and use those long curved tusks almost like shovels, sweeping the drift aside to reach the frozen grass hidden underneath. There is something oddly patient about it. An animal the size of a small house quietly working for its dinner one slow sweep at a time. They are not alone out there. Woolly rhinoceroses graze beside them, built low and heavy with a broad flattened horn that some scientists believe was used to sweep snow aside and reach the frozen grass underneath. Herds of reindeer move by the thousands, kicking up clouds of fine dry snow. And somewhere at the edges of the grassland in the long shadows, cave lions, noticeably larger and heavier than the lions we know today, watch and wait and do not move. And not far from that herd, tucked into a shallow valley just enough to break the worst of the bitter chill, there is a small circle of shapes that do not look like they belong in this world at all. Not caves, not simple tents, houses built almost entirely from bone. This part is not imagination. In 1965, a farmer in a small village called Migrate, not far from Kiev in Ukraine, was digging out space for a cellar when his shovel struck something enormous. It turned out to be the lower jaw of a woolly mammoth. What his digging eventually uncovered were 4 ancient huts built from 149 mammoth bones in total, stacked and fitted together with a kind of patience that is hard to picture today. Heavy skulls and hip bones formed the base of the walls. Long curving tusks arched overhead like the ribs of some impossible upside-down ship. Animal hides stretched tight across the bone framework kept out the bitter cold and the worst of the weather. These homes are thought to be around 15,000 years old, and inside one of them, archaeologists found something that makes you stop for a moment, a small curved piece of tusk carefully scratched with lines and shapes that many researchers believe form a map of the very land these people called home. In another hut nearby they found the skull of a mammoth painted with careful dots, and lines of red ochre curved and hollow like a great strange drum. Nobody knows for certain what it sounded like struck in the dark on a long winter night, but it is difficult not to imagine it. A slow, deep sound carrying just a little way out into all that white silence. Picture the inside of one of those huts on a night not so different from this one. A fire burning low at the centre, smoke curling up and out through a gap left in the hide roof above it. A few adults, a scatter of children wrapped in fur listening to somebody older tell a story they have probably heard 100 times before. Nobody seems to mind hearing it again. Outside, the cold air pushes hard against the hide stretched over old curved bone, but in here it barely reaches you. Think about that for a moment. In a world locked in ice deep enough to bury a skyscraper with nothing but bone-hide fire, and each other people built homes. They mapped their world. They made music or something close enough to it. They almost certainly told stories gathered close for warmth, the same as we are doing right now, waiting out a long cold night together. It is strange and oddly comforting to realize some things about being human never really change. We still gather in the dark. We still tell each other stories to make the cold feel a little smaller and the night feel a little shorter. The only real difference is that they had mammoth hide and a fire that needed constant feeding, and most of us just have central heating and a decent blanket. Somehow, I think we got the better deal. Now, here is where the story turns strange. That frozen world you just pictured was not a one-time event. It was not some rare accident tucked away in Earth's long history. Deep in Antarctica, scientists have drilled straight down through the ice, all the way to layers that first formed 800,000 years ago, and inside that ice trapped in bubbles smaller than a grain of rice. They found something like the planet's own memory written out in frozen air, and what that memory shows is this. 8 separate times across those 800,000 years, Earth slid into a deep freeze almost exactly like the one we just pictured together, and 8 separate times it climbed back out again, not at random, not once every few thousand years and then again whenever it felt like it. Roughly patiently again and again, close to every 100,000 years, this planet has breathed in and breathed out, freezing and thawing over and over, long before anyone was ever around to notice the pattern. Picture a clock with a hand so slow it takes 100,000 years just to complete a single turn. Slower than a heartbeat, slower than the seasons, slower almost than memory itself, and yet every bit as steady. That is in effect what Earth has quietly been doing since long before the first human ever struck 2 stones together to light a fire. Here is something worth sitting with for a moment. That ice record stretches back 800,000 years. Our own species, the one telling this story and the one listening to it, did not even exist yet when it begins. We would not show up for roughly another 500,000 years. Whatever has been driving this slow, patient rhythm was already ancient long before we ever arrived to notice it, let alone ask why. For most of human history, people blame the cold on gods, on curses, on the shifting moods of a restless sky. It took an extraordinarily long time for anyone to seriously consider a stranger, far quieter possibility that the freezing and thawing of an entire planet might have nothing to do with anger or punishment or chance at all, and everything to do with patient, precise mathematics playing out far above our heads, completely indifferent to whether anyone down here was watching. So here is the real question, the one that has quieted rooms full of scientists for more than a century. What could possibly force an entire planet again and again onto such a steady, patient rhythm? It was not a comet. It was not a single volcano or a single storm or any one dramatic disaster you could point to and say, there, that did it. Whatever has been doing this is quieter than that. Something built into the very way our planet moves through space, so subtle that for most of human history nobody even thought to look up and ask. And the answer, when it finally arrived, came from one of the strangest, most unexpected places imaginable. But before anyone could explain why the ice kept coming and going, they first had to prove beyond doubt that any of this had truly happened at all. And strangely enough, that first proof was not found in ice. It was found in rock. Enormous out-of-place boulders sitting alone in green Swiss valleys, as if they had wandered in from somewhere impossibly far away, as though some giant hand had simply set them down in the wrong country and walked off without them. For a long time nobody could explain how they got there, and for a while almost nobody even wanted to try. But once people finally accepted that those stones were telling the truth, an even bigger question opened up right behind it. If the ice truly came and went the way the rock seemed to insist again and again, then what in the sky above us could possibly be pulling the strings? That mystery, the mystery of the wandering stones, is exactly where our story goes next. Just outside a small city in Switzerland called Neuchâtel, there is a quiet forest on a hillside, and standing alone among the trees, half swallowed by moss, is a single rock roughly the size of a house. Locals call it Pierre Rabot. It weighs close to 3,000 tons, which is heavier than the Statue of Liberty base, and all several times over. And here is the strange part. Geologists who studied its granite discovered something that should not be possible. That rock did not come from anywhere near that hillside. It came from the Mont Blanc Massif over 60 miles away on the far side of a mountain range. Now stop and think about that for a second. A boulder the size of a house sitting quietly in a forest made of stone that belongs to a completely different mountain, more than 60 miles in the distance. Have you ever driven past something like that yourself? One enormous, lonely rock sitting in the middle of a flat field or a forest with no cliff nearby. Nothing it could have possibly rolled down from. If you have, you are looking at a small, silent piece of exactly the kind of mystery we're about to walk through together. For centuries, nobody in Europe had a good answer for stones like this one. And to be fair to those early thinkers, the explanation they landed on was not some lazy guess. In the early 1800s, most respected geologists believed these boulders had been carried by a colossal ancient flood, the same flood described in the Book of Genesis sweeping enormous rocks across the continent as the waters receded. This was not a fringe theory. This was mainstream science defended by serious, well-trained scholars in serious academic journals. It simply happened to be wrong. To be fair to those scholars, this was not really a case of stubborn belief standing in the way of clear thinking. Many of the leading geologists of that era were not defending old religious ideas so much as defending the best working model available to them at the time. Sudden violent events, floods, earthquakes and landslides fit neatly with the evidence directly in front of them. The notion that ordinary ice creeping forward slower than a garden snail could somehow reshape entire continents, given enough centuries, sounded to most trained minds far less believable than one dramatic flood. Being wrong and being foolish are not always the same thing, and this is a fairly good example of that. The first real crack in that theory did not come from a university at all. It came from a chamois hunter named Jean-Pierre Perraudin, who spent his life climbing through the Alps chasing wild goats across the high valleys. Perraudin kept noticing something odd. Deep scratches on bare rock running in long straight lines, high up on mountainsides where no river had ever flowed. Smooth polished stone in places a flood could never have reached. He became convinced that these were not signs of water at all. They were the fingerprints of ice, of glaciers that had once been far larger than the ones still clinging to the peaks above his village. Nobody listened to a hunter, of course. So Perraudin brought his idea to a Swiss engineer named Ignaz Venetz, who had the credentials people were willing to take seriously. Venetz studied the evidence for himself, quietly became convinced and spent years trying to persuade the scientific community with very little success. In 1821 he finally presented his findings to the Swiss Society of Natural Sciences, the very same society that would 16 years later host a far more famous speech in Neuchâtel. It went over about as well as you might guess. The members thanked him politely, filed the paper away and returned to other business. Venetz had been essentially correct 16 years ahead of the moment history now remembers, and outside a small circle of Alpine villages almost nobody learned his name for it. Eventually he managed to convince one more man, a mine director named Jean de Charpentier, who began collecting more and more proof across the Rhône Valley. And this is where our central figure finally enters the story. In 1836, a young, brilliant and rather ambitious naturalist named Louis Agassiz went to stay with Charpentier for several months in a village called Bex. Agassiz was already well known for his work on fossil fish, and by most accounts he arrived fully intending to gently talk his host out of this glacier nonsense. Instead, Charpentier took him hiking through the Alps and showed him the scratches, the polish, the debris fields piece by piece. By the end of the trip, Agassiz had done a complete turnaround. He did not just accept the glacier theory. He became its most passionate, most relentless champion. Here is a small human detail worth sitting with. It is rarely the person who has the idea first who ends up remembered for it. It is very often the person who arrives skeptical gets convinced by the evidence and then refuses to let the idea go. That was Agassiz's real gift. Not the discovery itself, but the stubbornness that came right after it. The following year, on the 24th of July 1837, Agassiz stood up to deliver the opening address at a meeting of the Helvetic Society of Natural Sciences in Neuchâtel. Everyone in that hall was expecting to hear more about his fish research. That is what the programme said. That is what Agassiz himself was supposed to be presenting. Instead, he set his notes on fossil fish aside completely, and for the first time in front of a major scientific audience, argued that the Alps had once sent enormous rivers of ice pouring out across the plains of Europe, burying entire regions we now consider warm and green. You could probably hear the room go quiet. One detail from that very same meeting almost never makes it into the story, and I think it deserves to. A botanist in attendance named Carl Schimper, a friend of Agassiz's who had also been circling around these same ideas, coined a phrase in a private note that day to describe this vanished world of ice. He called it in German Die Eiszeit, the Ice Age. That is where the term we still use today was actually born quietly on the sidelines of a lecture most of the audience found close to unbelievable. And unbelievable is putting it politely. The backlash was immediate and fierce. Alexander von Humboldt, one of the most respected scientists alive at the time, wrote to Agassiz essentially warning him that he was wasting his considerable talent, chasing an eccentric side theory, and that he ought to return his full attention to fossil fish, where his reputation was actually secure. Other prominent geologists dismissed the whole idea outright. To most of the establishment, Agassiz had traded a promising respectable career for what looked like a stubborn, embarrassing obsession. Here is a question worth asking yourself honestly. If nearly every expert you respected told you that your best idea was a career-ending mistake, would you have the nerve to keep going anyway? Agassiz did. And rather than trying to argue his way out of the criticism, he did something far more effective. He went back to the mountains to gather more proof than anyone could reasonably dismiss. Starting in 1840, Agassiz and a small team of collaborators set up what might be the most charmingly ridiculous research station in the history of science. High on the Unteraar Glacier, they wedged a simple shelter beneath the overhang of an enormous boulder, and they nicknamed it, only half-joking, the Hôtel des Neuchâtelois, the Hotel of the Neuchâtelers. If you are picturing a fireplace and a warm bed, let me correct that image right now. It was a gap under a rock on top of moving ice at roughly 8,000 feet above sea level, and it was Agassiz's home on and off for 5 summers. From that freezing little rock shelter, the team ran experiments that had never been attempted before. They drove iron stakes directly into the surface of the glacier in a long row and measured month after month exactly how far the ice carried them. The centre of the glacier, they discovered, crept forward well over 100 feet some years, while the edges dragged behind, slowed by friction, against the rock walls, proving that a glacier does not just sit there. It flows slowly, like an impossibly thick, impossibly patient river. Using a heavy iron drill attached to a hand winch, they bored more than 150 feet down into the ice itself, deep enough to prove the glacier was far thicker than anyone had assumed, though still nowhere near its actual bed. At one point, driven by simple curiosity, Agassiz climbed down into a crevasse himself, lowered by rope, into the blue, silent interior of the glacier, just to see what was down there. Whatever you think of him, the man did not lack nerve. It is worth saying, too, that Agassiz and his small circle of scientists were not out there entirely alone. Local mountain guides, men who had worked around that glacier for most of their lives, helped haul the equipment, cut the shelter into shape, and kept the whole expedition alive through 5 difficult summers. If you ask me, those guides had probably already worked out most of what the experiments eventually proved simply from decades of quietly watching the ice creep forward each winter and pull back a little every summer. That kind of knowledge just was not the sort that made it into a scientific journal in those days, and it is worth remembering them here even briefly, even without most of their names surviving. And piece by piece the evidence became impossible to wave away. Match the rock type of a stray boulder to its home mountain, and you could trace exactly how far the ice had carried it. That very Pierre Abeau boulder we started with, the one sitting quietly in the forest near Neuchâtel, was eventually traced back to the granite of the Mont Blanc Massif, dragged there by the ancient Rhone glacier during a colder chapter of the past, one that geologists now believe ended somewhere around 20,000 years ago. Long parallel scratches on exposed bedrock hundreds of miles from any modern glacier matched exactly the kind of striations still forming under the ice in the Alps today. Mounds of jumbled rock and debris called moraines appeared again and again in valleys with no glacier left to explain them. One boulder is a curiosity. A handful of scratched rocks is a coincidence, maybe. But an entire continent covered in the same repeated pattern, the same fingerprints over and over in places thousands of miles apart, stopped being a coincidence and started looking like a fact the world had simply never noticed before. In a strange way, it is not so different from how a detective builds a case today. No single piece of evidence proves much on its own. It is the pattern repeated in places too far apart to be an accident that eventually makes a story impossible to deny. It took decades, not months, for the wider scientific community to come around. Old ideas rarely surrender quickly, no matter how much evidence stacks up against them. But slowly through the 1840s and 50s, the flood theory lost ground valley by valley, boulder by boulder, until Agassiz himself could later write to a friend that the reality of past glaciation was now regarded among geologists as settled fact. By then, Agassiz had already left Switzerland behind. In 1846, he sailed for the United States, arriving in Boston to give a series of lectures that were meant to last a single season. He never really left. He took a position at Harvard, and almost immediately he began noticing the same telltale scratches and polished bedrock scattered across New England. Have you ever stood in a field somewhere in Massachusetts or Vermont or upstate New York and noticed a scattering of large rounded rocks that seem to have no real business being there, with no cliff or quarry anywhere close enough to explain them? If you have, you are standing on top of the very same kind of evidence Agassiz went looking for. The same stray boulders sitting in fields with no local source, the very landscape we stood inside together earlier in this story. Agassiz became convinced correctly that the same vast ice sheets that had once buried Switzerland had also in an earlier chapter buried much of North America. He spent the rest of his career in Massachusetts, and when he died in 1873, his family chose a fittingly strange headstone. Not polished marble. A rough, weathered boulder shipped all the way from the moraine of that same Unteraar glacier, from almost the exact spot where the old Hôtel de Neuchâtelois once stood. A glacial erratic marking the grave of the man who taught the world what glacial erratics actually were. There is something quietly moving about that if you sit with it for a moment. A man spends his life trying to convince the world that ice once moved mountains of rock across entire continents, and in the end his own grave becomes one more stone carried a very long way from home. I think what strikes me most about this whole chapter of the story is not really the science. It is how ordinary the process of discovery turned out to be. No sudden flash of insight, no single genius working alone. A hunter noticed something odd. An engineer took him seriously. A mine director followed the trail further. A stubborn young scientist got talked into looking properly, got convinced despite himself, and then refused to back down even when nearly everyone he respected told him to stop. That is how most real discoveries actually happen, quietly, slowly, and usually against considerable resistance. But proving the ice had once existed was really only the beginning of the mystery, not the end of it. Agassiz and his generation could point to the scratches, the boulders, the moraines, and say with total confidence this happened. What none of them could explain, not Agassiz, not Charpentier, not anyone else standing in that lecture hall in Neuchâtel, was why. It is a bit like finding a footprint in fresh snow. The footprint proves beyond any argument that somebody walked through. It tells you nothing at all about where they were headed or why they set out in the first place. Why would an entire planet swing between deep, punishing cold and comfortable warmth in the first place? What could possibly turn that switch on, and later turn it off again? That question would sit unanswered for the better part of a century, waiting for someone patient enough, and frankly stubborn enough, to actually sit down and do the math. As it turned out, the person who finally cracked it was not working in a university or a laboratory or a mountain hut of his own. He was doing it from inside a prison camp with nothing but pencil paper and an unreasonable amount of time on his hands. There is a particular kind of bad luck reserved for honeymoons, and the one belonging to a young Serbian professor named Milutin Milankovic might be the worst example history has on record. Let me back up a little first, because this man deserves a proper introduction before his life falls apart in front of us. Milankovic was not originally a scientist of the sky at all. He trained as a civil engineer in Vienna, earned his doctorate on the strength of concrete structures, and spent his 20s designing dams, bridges, and reinforced concrete buildings across the region we now call Serbia and Croatia. By most measures, he was already successful. Stable job, growing reputation, a name people trusted when they needed something built to last. He patented several of his own methods for reinforced concrete construction, and some of the bridges and buildings he helped engineer are still standing across the region today, quietly holding up traffic and pedestrians who have never once heard his name. And then, somewhere around 1911, sharing a bottle of wine with a friend one evening, he decided none of that was interesting enough anymore. He wanted a properly enormous problem to work on, something nobody had properly solved, and the one he picked almost on a whim was this: could the slow, invisible wobbles of a planet's orbit actually explain why ice ages come and go? Not just for Earth either. He wanted a single mathematical theory that could describe the climate of any planet in the solar system, using nothing but geometry, physics, and a stubborn amount of patience. He was not starting from nothing. A Scottish scientist named James Croll had proposed something similar decades earlier, tying ice ages to changes in Earth's orbit, but Croll's mathematics were not quite sharp enough to hold up against scrutiny, and his idea had mostly been shelved. Milankovic studied Croll's work, carefully respected what he had attempted, and quietly set out to do the version of it that would actually survive contact with real data. There was also a German mathematician named Ludwig Pilgrim, who'd already worked out fairly precise calculations for how Earth's orbit slowly stretches and relaxes over time. Milankovic studied those numbers closely too, treating other people's failed or unfinished attempts less like dead ends and more like a set of tools somebody had left behind half-built, waiting for the right person to come along and pick them back up. That was the plan anyway when he married a young amateur opera singer named Kristina Topuzovic in the middle of June 1914. The couple decided to spend part of their honeymoon in Milankovic's home village, a quiet spot called Dalj on the banks of the Danube. It should have been an easy, uneventful trip. It was not. Within days of their arrival, an assassin in Sarajevo shot and killed the heir to the Austro-Hungarian throne. Milankovic's home region at the time sat inside the Austro-Hungarian Empire, right on its tense, uneasy border with the Kingdom of Serbia. And Milankovic himself happened to be a reserve officer in the Serbian army, As tensions exploded into what would soon become the First World War, he was arrested practically still on his honeymoon and taken away as an enemy of the Empire. Newlywed with a wedding ring, barely a few weeks old, suddenly standing in a small room with stone walls, uncertain whether he would ever see his wife again, let alone finish a single page of his research. Try to sit with that for a second. 1 week you are marrying the woman you love. The next you are a prisoner and the whole continent is sliding into war around you. Here is the detail that turns this from a sad story into something closer to remarkable. When Milankovitch was taken into custody, he happened to be carrying a briefcase with him, containing a handful of his old scientific notes and some blank paper. Most people dragged away from their honeymoon into a prison cell would understandably fall apart for a while. Milankovitch, by his own account written years later, looked around that small room, and instead of despair felt something closer to curiosity. He treated it almost like a single overnight stop on a much longer voyage he was already taking in his head through the mathematics of the solar system. And that same night in his cell he opened his notebook and got to work. I do not think I am exaggerating when I say that is one of the strangest coping mechanisms in the history of science, and also possibly one of the healthiest. His formal imprisonment did not last terribly long, though it easily could have gone much worse. Christina, along with one of Milankovitch's old university mentors, pushed hard for his release, and eventually succeeded in getting the terms softened. Instead of a prison camp, he was paroled to Budapest, required to check in with the local police station once a week to prove he had not run off. Beyond that single weekly obligation for the next 4 years, an ocean of empty time opened up in front of him. Most people handed 4 unexpected years and very little else to do would probably struggle to fill them. Milankovitch walked straight to the Hungarian Academy of Sciences, introduced himself to the library director, and more or less moved in. For 4 years, while an entire world war ground on outside, he sat in that reading room working through calculation after calculation by hand. Every week without fail he made the same short walk from his lodgings to the local police station, signed whatever paper needed signing to prove he'd not slipped away, and then walked straight back to the same reading room, the same stack of paper, as though the appointment were nothing more than a minor interruption in his real work. Christina, by the way, was not simply a supportive bystander through any of this. She had trained as an opera singer entirely comfortable performing in front of large, unforgiving crowds, and by most accounts had exactly the kind of nerve and persistence needed to go toe-to-toe with wartime bureaucracy on her husband's behalf. His freedom to sit quietly in that library for 4 years did not happen by accident. Somebody fought hard on his behalf to make it possible. No calculators, obviously, no computers, just pencil-paper logarithm tables and an enormous amount of patience. He was trying to track with real mathematical precision exactly how the combined gravitational pull of the Moon, the Sun, Jupiter and Saturn slowly reshapes Earth's orbit, and the tilt of its axis over hundreds of thousands of years. Picture rows and rows of handwritten figures, page after page, each one feeding into the next building toward a single sweeping answer to a question almost nobody else was even asking anymore. To give you some sense of scale, a modern laptop could reproduce decades of this kind of orbital arithmetic in well under a second today. Milankovitch had none of that. Only tables, a slide rule, and stack after stack of handwritten pages accumulated over roughly 3 decades of steady, careful work. Every figure checked and rechecked by hand because a single misplaced decimal, buried somewhere around year 40, of a calculation stretching across hundreds of thousands of years, could quietly poison everything that came after it. And in case you're picturing a miserable, isolated existence, it was not entirely that. His wife joined him in Budapest. Their son Vasilie was born there in December of 1915, right in the middle of everything, somewhere between reporting to the police each week and filling notebook after notebook with orbital mathematics. Milankovitch was also simply living his life, raising a child, doing what people do, even while history was doing something considerably louder around him. By the time the war ended, he had produced the mathematical backbone of what would eventually become his life's defining work, a theory tying the timing of ice ages to 3 separate overlapping rhythms in the way Earth moves through space. He published an early version of it in 1920. Almost nobody noticed. Part of the problem was not really his mathematics. By the 1920s, most geologists already agreed that ice ages had happened thanks to men like Agassiz decades earlier. What nobody could yet do was date them with any real precision. Radiocarbon dating did not exist. There was no reliable way to look at a layer of ancient rock or sediment and say with confidence that it was 120,000 years old, rather than 80,000 or 200,000. Without accurate dates, there was simply no way to test whether Milankovitch's calculated rhythm actually lined up with when the ice had truly advanced and retreated. In a very real sense, his theory was unprovable, with the tools available at the time not because it was wrong, but because the rest of science had not yet caught up to the kind of precision his mathematics demanded. He kept refining it anyway for another 2 decades. In 1941, he finally finished his complete definitive statement on the subject, a dense volume summarizing roughly 30 years of work, titled in translation, Canon of Insulation and the Ice Age Problem. By the time it was finished, that book contained tables and curves stretching back roughly 600,000 years, predicting mathematically exactly when Earth's high northern latitudes would have received noticeably less summer sunlight than usual, and by his own theory exactly when ice ages should have begun and ended. And then, almost unbelievably, history repeated itself. Nazi bombs struck Belgrade that same year, destroying the printworks where his book was being assembled just as it neared completion. City occupied a month later. For a while it looked like decades of solitary labour might simply be erased. Fortunately, the warehouse holding the already printed pages had survived untouched, tucked away safely enough to escape the worst of the damage. The book was eventually pieced back together and published in full. Here is a question worth sitting with for a moment. Have you ever spent years working on something fully convinced you were right, with almost nobody around you believing it, and no real way to prove it yourself? That was Milankovitch's entire adult life, more or less from that prison cell in 1914 until the day he died, because the ridicule did not stop once the book came out. If anything, it got worse. Meteorologists dismissed his theory. Geologists dismissed his theory. Even decades later, well into the 1960s, one respected climate scientist would later recall attending a conference where colleagues openly mocked Milankovitch by name, treating his entire body of work as an embarrassing joke that refused to go away. Milutin Milankovitch died in 1958 in Belgrade, having spent close to 50 years defending an idea that most of the scientific world still considered close to worthless. He never got to see himself proven right. There is a real difference worth noticing here compared to the man we spent our last chapter with. Agassiz faced fierce resistance too, but within a couple of decades he lived to see his glacier theory largely accepted, even celebrated. Milankovitch was not so fortunate. He spent essentially his entire adult life defending an idea that the wider scientific world continued to treat as a curiosity at best and nonsense at worst, right up until his death. That is a much lonelier kind of persistence, and I think it deserves a little more recognition than it usually gets. The proof finally arrived in 1976, 18 years after he died. 3 scientists studying long cylinders of mud and clay dredged up from the floor of the ocean matched the timing of past ice ages against the exact rhythms Milankovitch had calculated by hand decades earlier in a library in Budapest. He was not alive to see it happen. Before we move any further, I want to give you one more piece of him because I think it says something honest about who he actually was underneath all that stubbornness. Late in his life, in 1955, already retired from teaching, Milankovitch published one final academic paper. It had absolutely nothing to do with ice ages. Inspired by an old painting of the Tower of Babel, he sat down and calculated purely as an intellectual exercise the tallest possible building that could theoretically be constructed on the surface of the Earth. His answer worked out to something over 20,000 meters tall, complete with a platform at the summit for astronomical and weather observation. A retired engineer, decades removed from concrete and steel, quietly returning to his very first love just because the question amused him. What is the strangest, most impractical question you have ever gone down a rabbit hole trying to answer? Purely because you were curious. I would honestly love to know, so tell me in a comment if one comes to mind. That to me tells you everything about the kind of mind we're dealing with here. Not somebody chasing fame. Somebody who simply could not stop asking enormous, slightly absurd questions, and then patiently working out the answers whether or not anybody else cared. For most of his life, nobody did. And I think that is worth remembering the next time you feel like the thing you are quietly working on alone late at night does not matter to anyone but you. Sometimes it takes the rest of the world several decades to catch up. His 3 great cycles sat there in his notebooks and published pages for years, essentially unread, unproven, treated as an eccentric footnote in the history of science right up until that quiet moment in 1976, when the sediment finally spoke on his behalf. But before we get any further into how that proof actually came together, I think it is worth slowing down and properly understanding what Milankovitch spent those 4 years in Budapest calculating in the first place. 3 slow, patient rhythms hidden in the way our planet spins and tilts and drifts through space, so subtle that almost nobody before him had ever managed to describe them properly. It turns out our planet does not simply orbit the sun in one clean fixed motion. It wobbles, it leans, it breathes in and out ever so slightly over tens of thousands of years. And once you actually see how those 3 separate wobbles work, the whole mystery starts to feel a little less like magic and a little more like watching an extraordinarily slow, extraordinarily patient machine. Grab a coin if you happen to have one close by, or just picture one clearly in your mind if you do not. Set it spinning fast on a hard table right up on its edge. For the first second or 2 it spins upright, clean and steady. Keep watching a little longer though, and something else starts happening. The coin begins to lean. It wobbles. The very top of it starts tracing slow, lazy circles in the air, even while the coin itself keeps right on spinning underneath. That wobble, the one right before a spinning coin finally gives up and topples over, is about the closest everyday object I can think of to what our entire planet has been quietly doing for billions of years, just stretched out over a pace almost too slow for a human mind to properly hold on to. This is what Milankovitch spent 4 years in a Budapest library trying to describe with actual numbers rather than just a feeling. Not one single wobble either. 3 separate overlapping ones, each moving at its own speed, each one nudging the amount of sunlight our planet receives in ways so small you would never notice them in a single lifetime, and yet large enough stacked up over tens of thousands of years to bury entire continents under ice. Let us take them one at a time because each one deserves a proper look. The first is the shape of Earth's own path around the sun. Most of us grew up picturing that path as a neat, perfect circle, and for practical everyday purposes that is a fine way to think about it. It is not quite true though. Earth actually travels in an ellipse, a very slightly flattened loop rather than a perfect circle, and the ellipse itself is not fixed. Over a period of roughly 100,000 years with a longer, gentler rhythm underneath it, lasting closer to 400,000 years, the shape of that loop slowly stretches and relaxes, stretches and relaxes again and again. If you scaled Earth's orbit down to fit on a dinner plate at its most circular, your eye would not be able to tell it apart from a perfect ring. At its most stretched over tens of thousands of years, that same ring would look like a circle somebody sat down on just a little too hard. A subtle difference visually. But on a planetary scale, subtle differences in shape translate into real differences in how close Earth swings to the Sun at certain points in its yearly lap, and how far it drifts away at others. Scientists call this one eccentricity, which is really just a fancy way of measuring how far a shape has wandered from being a perfect circle. To put an actual number on it right now across a single year, Earth's distance from the Sun varies by only a few % between its closest approach and its farthest point. During a stretch of high eccentricity tens of thousands of years from where we sit today, that gap widens considerably, meaning one particular point in the year runs measurably warmer or colder than it otherwise would, purely because the planet happens to be sitting closer to or farther from its one real source of heat. Right now, as it happens, we're living through a period when Earth's orbit sits fairly close to circular, which in a strange way actually makes our current stretch of stable climate a little bit of a lucky coincidence timing-wise. More on that later. Today, Earth's axial tilt sits at roughly 23.5 degrees, and it happens to be slowly drifting toward the gentler end of its range rather than the more extreme one. Two of the three great rhythms, in other words, currently happen to be leaning toward calm rather than toward extremes, which is one of several reasons our current stretch of mild, dependable climate has lasted as long as it has. We will come back to exactly why that matters a little later in this story. The second wobble is one you already know something about, even if nobody ever explained it to you this way. It is the reason we have seasons at all. Earth does not spin perfectly upright like a pin standing straight on a table. It spins at a lean tilted a little over 23 degrees off-center. That tilt is exactly why the northern hemisphere bakes in July and shivers in January, while the southern hemisphere runs on the opposite schedule entirely. Here is the part almost nobody gets taught in school, though. That tilt itself is not fixed either. Slowly, over a cycle of roughly 41,000 years, it rocks back and forth from about 22 degrees at its most upright to nearly 24.5 degrees at its most extreme lean and back again. Scientists call this one obliquity. Think about what that actually means. When the tilt leans further, summers at high latitudes run noticeably hotter, and winters run noticeably colder. Sharper seasons in both directions. But when the tilt straightens up, relaxing closer to that 22-degree minimum, summers at high latitudes turn cooler and gentler than usual. And here is the piece of this whole puzzle that truly caught me off guard the first time I properly understood it. Ice ages not really triggered by winters becoming unbearably cold. Winters in most of the northern hemisphere are already cold enough to produce plenty of snow in an ice age or not. What actually matters is the summer that follows. If that following summer is just slightly too weak, too cool to fully melt what fell the previous winter, then a little bit of that snow survives. The next winter adds more on top. The summer after that, still too weak, fails to clear it again. Repeat that pattern for a few thousand years running, and you're no longer talking about a heavy winter. You're talking about the birth of an ice sheet, one thin, stubborn layer at a time. Have you ever noticed how some summers, even within your own lifetime, just feel a little weaker than others, a little less committed to actually being hot? Now stretch that same feeling out, one unremarkable summer after another for several thousand years running, and you start to understand exactly how an ice age actually gets its start. Not with a bang, with a shrug. It is a strangely quiet way for something so enormous to begin. Not a sudden freeze, a summer that simply did not try quite hard enough several years in a row. Which brings us to the third wobble, the one our spinning coin was actually demonstrating a few minutes ago. Earth's axis does not just tilt at a fixed angle relative to the stars. The direction that tilt points toward is itself slowly drifting, tracing a wide, lazy circle across the sky, the exact same way the top of a spinning coin traces circles right before it falls. Scientists call this one precession, and on its own, purely as an axis pointing exercise, it takes roughly 26,000 years to complete one full loop. Here is a fact I happen to love because you can actually verify it with your own eyes on a clear night. Right now, if you find the North Star, you're looking at the direction our planet's axis currently happens to be pointing. Polaris has not always held that title though, and will not keep it forever either. Thousands of years ago, a completely different star sat at that spot in the sky. Roughly 12,000 years from now, a bright star called Vega will take over the job instead. Our entire sky over long enough stretches of time quietly rearranges itself above our heads. Have you ever looked up at the North Star and simply assumed it had always been sitting exactly there forever unmoving? I certainly used to think that before I properly understood any of this. It is a strange thing to sit with that the fixed points we navigate by, quite literally the stars sailors have steered ships by for thousands of years, are not fixed at all. They only look permanent because they move slowly enough that a single human lifetime can never quite catch them in the act. Now this wobble matters for our story for a very specific reason. As that axis slowly traces its circle, it changes which season lines up with Earth's closest pass by the Sun each year. Right now, Earth happens to swing closest to the Sun in early January, right in the middle of Northern Hemisphere winter, which very slightly softens our winters and very slightly cools our summers here in the north. Roughly 11 or 12,000 years from now, thanks to this same slow wobble, that alignment will flip. Earth will swing closest to the Sun during Northern Hemisphere summer instead, which tends to sharpen summer heat rather than soften it. When you fold this precession cycle in with the shape changes of the orbit itself, the climate-relevant version of this wobble settles into a rhythm closer to 23,000 years, rather than the simpler 26,000-year figure for the axis alone. 3 separate rhythms then, one roughly every 100,000 years, one roughly every 41,000 years, one roughly every 23,000 years. 3 hands on an impossibly slow clock, each one turning at its own speed, sometimes lining up to reinforce each other, sometimes pulling in opposite directions and cancelling each other out almost entirely. Here is something worth pausing on. All 3 of these rhythms do actually matter everywhere on the planet, mathematically speaking, but they matter most by a wide margin in one very specific place. Roughly 65 degrees north latitude, the band that runs through Siberia, northern Canada, Scandinavia and Greenland. Why there specifically, and not say 65 degrees south down near Antarctica? Land. Simple as that. The Northern Hemisphere happens to have enormous stretches of exposed continental land sitting at these high latitudes land that can accumulate snow hold onto it and reflect sunlight straight back into space once it does. The Southern Hemisphere at that same latitude band is mostly open ocean, which behaves completely differently. Water absorbs heat instead of reflecting it away, and it moves and mixes and resists holding a stable layer of ice the way solid ground can. Picture pouring a tray of water onto 2 different surfaces. Pour it onto solid flat ground and it pools settles, and if the temperature drops far enough it freezes right in place and stays there. Pour that same water into a moving current instead, and it gets carried off, stirred around and warmed back up almost immediately. Land behaves like the first surface. Ocean behaves like the second. That, in the simplest terms I can manage, is why one hemisphere quietly grows ice sheets across the ages and the other mostly does not. So even though every square inch of the planet technically experiences these three wobbles, equally the actual physical response, the part where ice sheets are born or melted away, plays out overwhelmingly in the north. That is precisely why Milankovitch spent so many of his calculations obsessing over one narrow specific number: how much sunlight reaches 65 degrees north during the summer months in any given stretch of thousands of years. Everything else in his theory flows outward from that single carefully calculated figure, and the swings involved are not small once all three rhythms happen to line up in the wrong direction at once. Researchers studying these cycles have found that the total heat reaching the top of the planet during summer can shift by close to a fifth, purely because of these three orbital rhythms working together. A fifth. Not from the sun burning any brighter or dimmer. The sun's actual output barely changes at all across these cycles. This is purely about geometry, about exactly where and precisely when that same steady sunlight happens to land. Consider this for scale. Global average temperature has only shifted by somewhere around 9 or 10 degrees Fahrenheit between the deepest cold of a true ice age and the warm comfort most of us take for granted today. That narrow band covers the entire distance between a frozen half of the planet and the world we currently think of as normal. A shift of a fifth in summer sunlight, concentrated at exactly the latitude that matters most, is more than enough to help tip that whole balance in either direction. That is worth clarifying clearly actually, because it trips a lot of people up. Ice ages are not caused by Earth drifting further away from the sun overall, the way some people imagine picturing our planet slowly wandering off into colder space. Earth's average distance from the sun barely changes at all across these cycles. What changes is the tilt, the timing, and the shape of the path we travel, all of which quietly reshuffle exactly how sunlight gets distributed across the seasons and across the hemispheres. Same sun. Same total energy, more or less. Just a different, constantly shifting pattern of where that energy actually falls. I find something oddly comforting about that idea, honestly. Nothing violent has to happen for a planet to slide into an ice age. No explosion, no catastrophe, no sudden external shock. Just three quiet, patient rhythms doing exactly what they have always done, occasionally lining up in just the wrong combination, for just long enough for snow to start winning a very slow argument against summer. This is the theory Milankovitch carried out of that library in Budapest, and spent the rest of his life defending essentially alone against a scientific community that was not remotely ready to believe him. Three interlocking wobbles, each one perfectly real, each one mathematically provable, and yet for decades utterly unconfirmed by anything you could actually hold in your hand or point to in the rock. We already know part of how this story ends. Back in 1976, those cylinders of ancient sediment pulled up from the ocean floor confirmed that Milankovitch's rhythm really had been governing Earth's ice ages all along, exactly as he calculated decades earlier in that quiet library in Budapest. But that discovery was really only the opening chapter of a much longer investigation, not the end of it. Scientists did not stop at the ocean floor. They went looking for an even cleaner, even more precise record of the past, and found it in about the most unlikely place imaginable. Locked inside layers of ice at the very bottom of the world, stretching back further into time than almost anyone thought a single continuous record ever could. There is a place on Earth so cold that if you threw a cup of boiling water straight up into the air, it would never come down as water at all. It would freeze mid-flight, scattering as a shimmering cloud of ice crystals before it ever reached the ground. That place has a name. Vostok Station, deep in the interior of Antarctica, sitting on top of more than 2 miles of solid ice. In July of 1983, a thermometer there recorded a temperature of negative 89.2 degrees Celsius, negative 128 degrees Fahrenheit. It remains to this day the coldest temperature ever reliably measured on the surface of our planet. For comparison, dry ice, the kind used to keep food frozen during shipping, sits at around minus 109 degrees Fahrenheit. Vostok's record cold was still nearly 20 degrees colder than that. At that temperature, ordinary steel turns brittle enough to shatter like glass. Diesel fuel thickens into something closer to sludge, and human breath does not simply fog the air. It crystallizes quietly audibly into tiny falling flecks of ice. Here is a question worth asking yourself honestly. Why would anyone choose to build a research station in what is by a wide margin the single most punishing location on the entire planet? The answer has nothing to do with the cold itself. It has everything to do with what lies underneath it. Would you volunteer to spend a winter somewhere like that even for the sake of one of the great scientific discoveries of the modern era? I have to be honest with you. I am not sure I would have the nerve. Vostok sits above the thickest, oldest, most undisturbed stretch of ice anywhere on Earth. And that ice, it turns out, is not just frozen water. It is memory. Every single snowfall that has ever landed there for hundreds of thousands of years running has been quietly pressed down, compacted and buried by the next one, and the one after that layer stacking on layer all the way down like the world's slowest, most patient filing cabinet. The Soviet Union established Vostok Station in 1957, and within a couple of decades, scientists there realized something remarkable. If you could drill straight down through that ice carefully, without disturbing the layers on the way, you would not just be drilling through frozen water. You would be drilling backward through time itself. They began in 1970. I want you to sit with the scale of that undertaking for a moment, because it is easy to breeze past a sentence like drilling began in 1970 without appreciating what it actually meant on the ground. This was not a quick weekend project. Supplies reached the station once a year, hauled in by a tractor convoy that crawled roughly 900 miles across open ice, taking weeks to make the journey each way. Drill heads froze solid a kilometer down and had to be painstakingly worked free. Every single piece of equipment had to survive temperatures that would make most modern machinery simply stop functioning. And the researchers themselves, mostly Soviet scientists working with limited funding and limited comfort, kept going anyway, year after year, drilling a little further down each season, one careful meter at a time. There was also a serious engineering problem to solve along the way. Ice under the sheer weight of more than a mile of ice sitting above it behaves less like a solid and more like an extremely slow, extremely thick liquid. Left alone, a borehole drill that deep will simply squeeze itself shut again within days. To stop that from happening, engineers had to continuously fill the hole with a special drilling fluid as they worked dense enough to push back against that immense pressure and keep the passage open long enough to lower the drill and haul up each new section of core. By 1985, after 15 years of that kind of grinding persistence, they finally pulled up something extraordinary. A continuous, unbroken cylinder of ice clear as glass in places that stretched back through an entire glacial cycle. 160,000 years frozen, layered and intact, sitting in their hands. Have you ever held something and known immediately that you were holding proof of an idea nobody had ever been able to properly prove before? That is roughly what this moment must have felt like. So how does anyone actually pull a story out of a cylinder of ice? It comes down to two separate signals, both hiding in the same frozen column, and both worth understanding properly, because they are wonderfully clever. The first signal is the ice itself. Water is not quite as simple a molecule as it looks. Some of it is built from a very slightly heavier version of hydrogen or oxygen than usual, and the ratio between the light and heavy versions in any given snowflake depends in a wonderfully precise and predictable way on how cold it was when that particular snowflake formed. Colder conditions favour the lighter version. Warmer conditions allow a little more of the heavier version to slip in. So by carefully measuring that ratio at every single depth in the ice core, scientists can reconstruct with real confidence roughly how cold or warm it was at that exact spot in that exact year, tens or hundreds of thousands of years ago. The ice itself works like a built-in thermometer one that never needed batteries or a human witness silently recording the temperature of every single snowfall since the day it landed. The second signal is even stranger and honestly my favourite part of this whole story. As snow slowly compacts into ice, it does not manage to squeeze out every last trace of the air trapped between the individual snowflakes. Tiny bubbles get sealed inside, instead permanently locked into the ice as it hardens. Those bubbles are not some indirect clue about the ancient atmosphere. They are the ancient atmosphere. Actual air breathed by nobody, touched by nothing, sitting completely undisturbed for 100,000 years or more, waiting patiently to be released the moment scientists finally cracked open that section of the core. Think about that for a second. Somewhere in a freezer in a laboratory today, there are sealed glass vials holding air that last existed as a gas, back when woolly mammoths were still walking across frozen grassland air that has not touched a single living lung in all that time, waiting quietly to finally be measured. It is worth clearing up a common misunderstanding here. Many people assume an ice core is mainly a record of how cold it used to be and nothing more. The temperature story is really only half of what makes this record so remarkable. The other half, that trapped ancient air, may be even more important because it lets scientists measure the actual greenhouse gas content of the atmosphere directly, rather than guessing at it indirectly through some other proxy. It is a bit like the difference between reading a description of a meal second-hand and actually tasting a spoonful of it yourself, prepared exactly the way it was 100,000 years ago. Using those two signals together, temperature from the ice and the exact chemical makeup of the trapped air, scientists could finally do something nobody had ever managed before. They could lay out side by side on the very same timeline exactly how warm or cold the planet had been, and exactly how much carbon dioxide sat in the atmosphere, stretching back further into the past than almost any other continuous record on Earth. Now here is where our story quietly collides with the one we spent the last two chapters on. Once that Vostok temperature curve was finally laid out properly, researchers did the obvious thing. They compared it against the rhythm Milutin Milankovic had calculated decades earlier by hand in a library in Budapest, using nothing but logarithm tables and an almost unreasonable amount of patience. The two curves lined up, not roughly, not in a loose, generous way you would have to squint at charitably to accept. They lined up closely enough that there was very little room left for polite scientific doubt. The warm periods in the ice matched the periods when Milankovic's calculations said high northern latitudes should have been receiving strong summer sunlight. The cold periods matched his calculated dips just as cleanly. A theory that had spent the better part of 60 years being quietly dismissed as an eccentric curiosity was sitting there confirmed frozen solid in a 2-mile deep column of Antarctic ice. There is something worth pausing on here about how different these two forms of proof actually turned out to be. Milankovic's version of the truth existed only on paper, built entirely from abstract calculation, invisible to the naked eye, impossible to hold in your hands. The ice core version of that same truth was the exact opposite in every way. Physical, heavy, something you could actually pick up, turn over in gloved hands and inspect with your own eyes layer by frozen layer. Mathematics and matter arriving at the very same answer from two completely different directions decades apart from one another. There is something almost unbearably fitting about that if you think about it for a moment. The proof that finally validated one man's decades of lonely hand calculated mathematics turned out to be sitting the entire time at the coldest, most isolated, least hospitable place on the surface of the Earth. As if the planet itself had simply been waiting for somebody patient enough to come and ask it directly. It is worth mentioning too that this discovery survived through some fairly serious real-world turbulence of its own. By the time the fullest analysis of that early ice core was being carried out, the Soviet Union itself was collapsing, and funding for a remote Antarctic research station was unsurprisingly not exactly a national priority anymore. Rather than let the work die along with the budget, the Soviet team shared their precious ice core samples with a group of French scientists who helped carry the analysis forward. Politics fractured. Empires ended. A frozen cylinder of scientific evidence somehow kept moving forward anyway, passed carefully from one set of hands to another. That first full record, published in 1999 by a team led by the French glaciologist Jean-Robert Petit, stretched back roughly 420,000 years. Impressive by any reasonable measure. But scientists being scientists immediately wanted to know what an even older, even deeper core might reveal. That push led to a new effort, entirely a European collaboration this time, drilling at a nearby site called Dome C, roughly 2 miles down into the ice sheet, deeper than anyone had managed before. When that drill finally reached bedrock, the ice core in their hands stretched back 800,000 years into the past. You may remember from earlier in this story that this is precisely the record that revealed something rather remarkable. 8 separate distinct swings between deep ice age cold and comfortable warmth spread across those 800,000 years, each one lining up with Milankovitch's calculations, just as cleanly as the first shorter record had. What was once a promising match had become an unmistakable pattern, written in ice confirmed across nearly 1 million years of Earth's own quiet bookkeeping. Before we move on, I want to tell you about one more thing hiding beneath that same stretch of Antarctic ice, because it still quietly unsettles me a little, in the best possible way. While all this drilling was going on, scientists studying radar images of the ice sheet around Vostok noticed something strange tucked far beneath the surface. A perfectly smooth flat region roughly the size of Lake Ontario, sitting under more than 2 miles of solid ice. It took decades of further study to confirm what that flatness actually meant. There is a lake down there, an enormous body of liquid freshwater lake sealed beneath the ice sheet, kept from freezing solid by pressure and geothermal heat rising up from the rock below. Lake Vostok, as it came to be called, has likely been sealed off from the rest of the world, completely untouched by sunlight or open air, for somewhere between 15 and 20 million years. Whatever exists in that water, if anything does at all, has been evolving in total isolation, in complete darkness, under crushing pressure for a span of time that makes the 800,000 years we've just been discussing look almost recent by comparison. Scientists finally drilled down and reached the surface of that lake in 2012, more than 2 decades after its existence was first confirmed. Under the sheer pressure of 2 miles of ice pressing down on it, lake water surged straight up the borehole the moment the drill broke through and froze solid almost immediately. Nobody has pulled up a clean, uncontaminated sample of the water itself, not yet. That particular chapter of the story is still being written. Have you ever stood next to a lake and wondered what might be quietly living in the deepest, darkest part of it? Now imagine a lake nobody has ever actually seen with their own eyes, sealed away from every living thing on the surface of the planet since long before the first humans walked anywhere at all. I think what moves me most about this entire chapter of the story is not really the science itself, remarkable as it is. It is the sheer stubborn patience involved on every side of it. Milankovitch calculating by hand for 4 years in a library convinced of an answer nobody around him believed. And decades later, an entirely different set of scientists sitting through the coldest winters on the planet, drilling one careful meter at a time for years on end, just to finally test whether he had actually been right. Two completely different kinds of endurance separated by half a century, aimed at exactly the same quiet question, and once that question was finally answered, once the ice had spoken, and spoken clearly, you might reasonably assume the whole mystery was closed for good. Ice ages happen because of these three orbital rhythms confirmed in the rock, confirmed in the sediment, confirmed now in the ice itself. Case closed. Except it was not closed, not quite. Because buried inside that same 800,000-year record, once scientists looked closely enough, was a pattern that Milankovitch's own calculations never actually predicted. A rhythm that showed up clearly, undeniably in the ice, but that according to the mathematics itself should not have been anywhere near strong enough to leave a mark that size. The proof had arrived, but it had brought a brand new puzzle along with it, one that remains even today only partly solved. Here is a strange kind of mystery, and honestly it might be my favourite kind there is. Not the sort where nobody has the faintest idea what is going on. The sort where everybody can see the pattern clearly laid out right in front of them, plain as day, and still cannot fully explain why it is there. That is exactly where our story stands right now. Let us walk back through what we actually know for certain, because it is worth being precise about this before we get into the part nobody has solved. Milutin Milankovitch calculated three separate orbital rhythms, remember. A wobble in the shape of Earth's orbit repeating roughly every 100,000 years. A wobble in the tilt of Earth's axis repeating roughly every 41,000 years. And a wobble in the direction that tilt points repeating roughly every 23,000 years. All three of them nudging how much summer sunlight reaches the high latitudes of the northern hemisphere, and by his theory, all three of them nudging Earth toward or away from an ice age. When scientists finally checked that theory against the ice going back roughly 3 million years, something beautiful happened at first. For most of that stretch from around 3 million years ago down to about 800,000 years ago, ice ages really did follow close to a 41,000-year rhythm, exactly the tilt cycle Milankovitch's mathematics predicted. Clean, tidy, elegant science confirmed by careful measurement. Exactly the kind of ending this story would have had if it had decided to stop right there. It did not stop there. Somewhere around 800,000 years ago the rhythm changed, not gradually drifting. It shifted over a relatively short stretch of geological time from that clean 41,000-year beat to a much slower, heavier one closer to 100,000 years between major ice ages. Scientists call this shift the mid-Pleistocene transition, and to this day nobody has fully explained why it happened, or why that particular moment in Earth's history was the one where the whole rhythm decided to change gears. But here is the deeper problem, the one that turns this from an interesting quirk into a proper still unsolved riddle. Of Milankovitch's three rhythms, only one of them, the orbital shape wobble, actually operates on anything close to a 100,000-year cycle. And when you run the actual mathematics on how much that particular wobble affects the amount of sunlight reaching high northern latitudes, the honest answer is not very much. It is by a wide margin the weakest of his three signals. The tilt wobble and the direction wobble both push and pull on incoming sunlight far more forcefully than the orbital shape ever does. Try picturing it this way. Imagine three people trying to rock a heavy boat back and forth. Two of them are pushing with real substantial force. The third is barely leaning against the hull, more of a light touch than an actual shove. If you came back later and found the boat rocking violently, specifically in time with that third person's gentle little nudges, you would have every right to ask a very reasonable question. How is that possible? The weakest push in the group appears to be producing the strongest result. or if sound suits you better than boats, picture it this way instead. If you turned these three signals into music, the tilt wobble and the direction wobble would come through as clear, confident notes easy to pick out even in a noisy room. The orbital shape wobble, by comparison, would barely register as a whisper of static in the background present if you listened closely with the right equipment, but nowhere near loud enough on its own to explain the powerful driving beat that keeps showing up in the ice. That, in plain language, is what paleoclimate scientists call the 100,000-year problem, and it has been sitting there unresolved since researchers first properly noticed it decades ago. An American scientist named Wallace Brucker, working alongside a colleague named Jan van Donk, was among the first to spot the pattern clearly back in 1970 years, before the deep ice cores we talked about earlier were even fully analysed. Studying evidence from the ocean floor, they noticed that the dominant rhythm of ice age cycles over roughly the last million years did not line up neatly with the tilt cycle everyone had assumed was the main driver. It lined up instead with a 100,000-year beat the one cycle Milankovitch's own numbers said should be having the smallest effect of the three. Brucker did not have an explanation for it. He mostly just had the courage to point out clearly that the numbers were not adding up the way everyone expected, which is very often how real scientific mysteries actually begin. Brucker, by the way, was no stranger to noticing inconvenient details that everyone else had quietly learned to look past. Later in his career, a 1975 paper of his became widely credited with popularizing the very term global warming years before it became a household phrase. He had a habit across his long career of spotting the exact detail that did not quite fit and refusing to look away from it, simply because it was inconvenient. Have you ever noticed a pattern in your own life that made no logical sense given everything you thought you understood about the situation? That uncomfortable, slightly itchy feeling where the evidence is undeniable, but the explanation you are relying on simply does not cover it. That is roughly the position paleoclimate scientists have been sitting in for more than 50 years now. So what actually explains it? I want to be honest with you here in a way I think this particular topic deserves. There is no single universally agreed answer. What exists instead is a handful of serious, carefully argued possibilities, each with real scientific support behind it and each with real critics who are not fully convinced. Before I walk you through them, try a small experiment with me. Take a guess right now, purely on instinct, which kind of explanation feels most likely to you. Something about the shape of the land itself, perhaps. Something chemical hidden in the air, or something almost mathematical, some strange quirk of timing lining up just right. Hold on to that guess. I am curious whether it ends up matching any of the ideas scientists actually take seriously. One leading idea involves the ice sheets themselves changing the ground they sit on. Early in the Ice Age cycles, before roughly 800,000 years ago, thick layers of loose, crumbly rock and soil called regolith still covered much of the bedrock underneath places like the Canadian Shield. Ice sitting on that loose material could slide and shift relatively easily, melting away again in rhythm with the quicker 41,000-year tilt cycle. But repeated glaciation over hundreds of thousands of years gradually scraped that loose material away entirely right down to bare exposed bedrock. Ice sitting directly on solid rock behaves differently. It grips harder, builds thicker, and takes considerably longer to grow and eventually collapse. Some scientists argue that this slow one-way transition from loose rubble to scraped bedrock is exactly what stretched the rhythm out to something closer to 100,000 years. Picture the difference between building a sandcastle on loose dry sand versus building one on hard-packed clay. The loose sand version collapses and rebuilds easily, following whatever rhythm the tide happens to keep. The version built on packed clay holds its shape far longer, resists smaller disturbances, and only truly gives way once conditions turn decisively against it. Something similar on a scale of thousands of years and entire continents may have been quietly happening underneath the ice the whole time. A second idea points toward carbon dioxide. Ice core records show that carbon dioxide levels in the atmosphere do not just sit there passively while orbital wobbles do all the work. They rise and fall in step with the temperature swings, and quite possibly help drive them further in the same direction through feedback loops that amplify whatever small nudge the orbit provides in the first place. Under this idea, the weak, gentle push from the orbital shape wobble does not need to move the climate all on its own. It only needs to tip the very first domino. Shifting carbon dioxide levels and the ice sheets themselves reflecting sunlight back into space once they start forming can do the rest of the heavy lifting from there. A third idea borrows a concept from an entirely different corner of physics, something called stochastic resonance. The basic notion is a little strange, but bear with me because I think it is worth understanding properly. Some complex systems, when they already contain a certain amount of internal noise or instability, can respond to a very weak regular outside push in a wildly exaggerated way, almost like the outside signal is finding an existing crack in the system and quietly widening it rather than doing all the work by itself. Under this theory, Earth's climate system, already unstable and twitchy in its own right, might simply be primed to overreact specifically to that gentle 100,000-year nudge the same way a slightly unbalanced washing machine can start shaking violently once it hits one particular unremarkable spin speed. There is also a fourth possibility, a little less dramatic than the others, worth mentioning honestly. Some researchers argue the apparent 100,000-year rhythm is not really one clean cycle at all, but rather several shorter precession cycles stacking up in sequence, roughly 4 or 5 of them in a row, before conditions finally line up correctly for a deglaciation to actually occur. Under this reading, ice quietly builds for several 23,000-year cycles running, and only breaks free again once several of those cycles happen to align just right. It would look from a distance exactly like a 100,000-year rhythm, without there needing to be one single 100,000-year cause behind it at all. 4 serious explanations, each backed by real research, real data, and real disagreement between very smart people who have spent entire careers on this exact question. And here is the part I actually find most refreshing about all of it. Nobody in this field is pretending the matter is settled. The honest current answer, more than 50 years after Brucker first flagged the problem, is still something close to we are not completely sure yet. But here are our best working theories. I want to be careful and precise about exactly what is and is not actually in question here because I think it matters. Nobody serious in this field doubts that Milankovitch's 3 orbital rhythms truly drive the broad rhythm of ice ages, or that carbon dioxide traps heat, or that ice reflects sunlight back into space. Those particular pieces are about as settled as science gets. What remains honestly open is a narrower, more technical question underneath all of that. Exactly which mechanism or which combination of mechanisms explains why one specific weak signal ended up dominating the beat for the last million years. A precise mechanical detail still being actively debated, sitting inside a much larger picture that is not seriously in dispute at all. I think there is something worth sitting with in that admission, and I do not mean that as a criticism of the scientist involved. Quite the opposite. It would be easy to assume that a mystery once confirmed by ice cores and hand-calculated mathematics must be fully solved, wrapped up, filed away. Real science rarely works that way. Confirming that something happens and fully explaining exactly why it happens, on the precise rhythm it does, are 2 very different achievements, and closing the gap between them can take generations. It is worth remembering too that even Milutin Milankovic, sitting in that library in Budapest decades before any of this modern debate, was not working with the full picture. His mathematics were remarkable and largely correct, and yet the very cycle that ended up dominating the last million years of Earth's climate was, according to his own calculations, supposed to be the weakest player on the field. The man who finally proved ice ages follow the sky never actually knew about the biggest twist buried inside his own theory. That discovery was still waiting patiently for the scientist who came generations after him. If you enjoy a mystery that resists a clean, tidy finish, I think this one might quietly be the best kind. Not because nobody is trying to solve it, because plenty of very capable people are trying right now with better instruments and better models than Brucker or Milankovic ever had access to, and the answer is still stubbornly just out of reach. There is one more detail I want to leave you with here because I think it captures something important about how careful real science actually has to be. Right alongside the 100,000-year problem sits a smaller, quieter cousin of it, sometimes called the 400,000-year problem. Earth's orbital shape also carries a longer, gentler rhythm on top of the shorter one, stretching across roughly 400,000 years. If eccentricity really were driving the shorter cycle, as strongly as some theories suggest, you would reasonably expect that longer 400,000-year rhythm to leave an equally clear signature somewhere in the climate record too. In the older parts of the ice and sediment record, it barely shows up at all. Another loose thread sitting quietly beside the main one, waiting for someone to finally pull it properly. So where does that leave us? A theory that is broadly overwhelmingly correct, confirmed across nearly 1 million years of physical evidence, sitting right alongside one specific stubborn detail that still refuses to fully cooperate. I happen to find that combination far more interesting than a story with every single loose end neatly tied off. It means the people studying this today are not simply confirming old textbooks. They're still actively in the middle of figuring it out, and whatever the true complete answer eventually turns out to be, one thing about all of this remains completely undisputed. Whether the trigger came from bare rock shifting carbon dioxide, an unstable climate system finding a weak nudge to amplify, or several precession cycles quietly stacking on top of one another, the physical result out on the actual surface of the planet was staggering every single time it happened. Whole continents buried under ice thick enough to bury mountains. Sea levels dropping far enough to reshape the map of the entire world. And that staggering physical transformation, the part none of these competing theories dispute for a moment, is exactly where we are headed next. There is a country that appears on no map in no atlas anywhere in the world today. And yet every so often a fishing trawler dragging its nets across the bottom of the North Sea still pulls up something that should not be there. A barbed antler tool, a fragment of jawbone. Once, unmistakably, a human skull hauled up from the seabed along with a morning's catch of herring. Fishermen working those waters have been finding these strange out-of-place objects for well over a century now, long before anyone fully understood what they were looking at. For years, the pieces were treated as curiosities tossed back or shelved in a cupboard somewhere. It took a proper look at the bigger picture stitched together from thousands of individual unremarkable hauls for anyone to realize they were staring at the scattered remains of an entire vanished country. That drowned country had a name once. Archaeologists call it Doggerland, and for thousands of years it was not seabed at all. It was solid ground connecting what is now Britain to the coasts of the Netherlands and Denmark, a wide low landscape of river valleys, marshes and gentle hills teeming with deer, wild boar and the people who hunted them. At its largest during the depths of the last ice age, you could have walked from a hill that is now somewhere off the coast of Yorkshire all the way to what is now Amsterdam and never once gotten your feet wet. At its peak, before the long retreat of the ice began, Doggerland covered an area comparable in size to the entire United Kingdom, low marshy and rich with life. People sometimes call it the real Atlantis of northern Europe minus the myth, because unlike Plato's legendary island, this one is not folklore. Its existence is not seriously in question. Its outline has been mapped patch by careful patch, using seismic survey data originally collected by oil and gas companies, scanning the seabed for entirely unrelated reasons later pieced together by archaeologists into something close to an actual map of a country that no longer exists. For a long time, popular retellings of this story like to end it with a single dramatic night. Around 6,200 years before the modern calendar, an enormous underwater landslide off the coast of Norway, one of the largest ever recorded, sent a genuine tsunami racing across the North Sea. It is a real event well documented in the sediment, and it likely did devastate whatever low-lying settlements remained on the last scraps of Doggerland at the time. But here is where I want to be honest with you, rather than just tell you the version of the story with the best sound effects. More careful recent research suggests that Single Wave was probably not the tidy final full stop popular retellings like to give it. Doggerland had already been shrinking for thousands of years by that point, drowned gradually, inch by patient inch, as melting ice sheets fed a slowly rising ocean. The tsunami was a genuine catastrophe for the people caught in it. It was very likely not the single moment the land itself finally disappeared. Sometimes the truth is less like a single dramatic ending, and more like a long, quiet retreat, punctuated by one terrifying night somewhere in the middle of it. Have you ever looked out at a beach and wondered what might be sitting on the seabed just beyond where you can see, somewhere under the waves, off the coast of Britain right now? There are still tools and bones and the outlines of rivers that once carried real water, real fish, and real people going about entirely ordinary days. Now follow me halfway around the world, because Doggerland was far from the only country the ice quietly erased. On the opposite side of the planet, in what we now call Southeast Asia, an entire continent used to exist that no modern map shows either. Geologists call it Sunderland. At its largest extent, falling sea levels exposed enough of the seafloor to fuse the Malay Peninsula together with the islands of Sumatra, Java, Borneo and Bali into one single continuous landmass close to 1,800,000 square kilometers, in size roughly double the size of the entire nation of India. Elephants and water buffalo once wandered freely across open grassland, where you would today need a boat or a plane just to travel between neighbouring countries. Beneath the shallow waters of what is now the Java Sea, geologists have mapped the ghostly outlines of entire ancient river systems, valleys and floodplains, features that could only have formed under open sky on dry land long before the ocean rose high enough to swallow them. It is little like finding the skeleton of a forest at the bottom of a swimming pool. Sunderland had a strange kind of border, though one worth pausing on. To its east, the exposed seafloor abruptly stopped at a channel of truly deep ocean water, one that never fully drained no matter how low sea levels fell during any ice age. A naturalist named Alfred Russel Wallace, the same man who independently arrived at the theory of evolution around the same time as Charles Darwin, was the first to notice something strange about that particular stretch of water. Species on its western side looked distinctly Asian. Species on its eastern side looked distinctly Australian. Nothing that evolved on one side ever seemed to cross naturally to the other, even during the driest lower sea level stretches of the ice ages. Scientists still call that invisible boundary the Wallace Line, and it sits there today for exactly the reason Wallace suspected. Some barriers do not need to be tall to be absolute. They just need to be permanently, stubbornly wet. Between these two vanished lands and dozens of others just like them scattered around the globe, roughly 8% more of the Earth's total surface stood as dry, walkable ground during the coldest stretches of the ice ages than stands there today. An area larger than the entire continent of Australia once available for animals, and eventually people to simply walk across, now sitting quietly under open ocean. To put that figure in perspective, it is roughly the difference between our planet having 7 continents and having an unnamed 8th one simply waiting to be explored on foot. Let us come back across the Pacific now to a very different kind of Ice Age time capsule, one you do not need a boat or a diving team to visit. You can drive there if you happen to find yourself in the middle of Los Angeles, beneath a stretch of Wilshire Boulevard in the middle of one of the most built-up cities on the planet. Natural asphalt has been quietly seeping up out of the ground for tens of thousands of years. During the Ice Ages, this sticky, viscous tar created what paleontologists rather bluntly call a death trap. Picture a shallow, unremarkable-looking pool, its surface sometimes dusted with leaves, or a thin skin of water disguising the thick black tar waiting just beneath. An animal steps in without a second thought. Within a few strides, its legs are already sinking. Within a few minutes, no amount of struggling helps at all. Its distress would draw in predators looking for an easy meal, who then found themselves stuck in the exact same trap. Over thousands of years, one accident at a time, the La Brea tar pits quietly assembled one of the richest collections of Ice Age skeletons found anywhere on Earth. The sheer numbers involved are worth sitting with. Researchers there have recovered the remains of well over 1,000 dire wolves, enough that a single wall of the museum today is lined with hundreds of their skulls, staring out in almost military rows. Alongside them, saber-toothed cats, an animal so central to the site that it is officially California's state. Fossil, short-faced bears built larger than any bear alive. Today ground sloths the size of a small car, and American lions noticeably bigger than the lions currently living in Africa. The trap did its grim work for tens of thousands of years, from roughly 50,000 years ago, right up until the final stretch of the Ice Age itself. Altogether, excavators have pulled more than 3.5 million individual bones out of that asphalt, representing hundreds of species, everything from towering Columbian mammoths down to beetles and pollen grains, small enough to need a microscope to even notice. Have you ever visited a museum and stood in front of a fossil, trying honestly to picture the living, breathing version of it, walking around in the exact spot where you are standing? At La Brea, that exact spot is a public sidewalk, a few blocks from art galleries and coffee shops in the middle of one of the largest cities in the United States. Ice Age Los Angeles is not some distant foreign landscape. It is sitting directly underneath the modern 1-1 thin layer of pavement away. Let us head north now, because Los Angeles was far from the only piece of the modern United States quietly shaped by the ice. Sitting on top of what is now the northern United States and much of Canada, remember, was that same Laurentide ice sheet we spent time with earlier in this story in places nearly 2 miles thick. As it finally began retreating roughly 20,000 years ago, it did not just melt away quietly. It gouged. Enormous lobes of ice, heavier and more patient than anything else on the surface of the planet, carved deep basins into the softer rock beneath them, then left ridges of rubble called moraines damming the meltwater in behind. Those flooded, ice-carved basins are the 5 Great Lakes you can find on any modern map of North America today. Together they now hold about 1/5 of all the liquid fresh water sitting on the surface of the entire planet. An amount of water so large it could cover the whole of the continental United States to a depth of roughly 10 feet, all traceable back to a single retreating wall of ice. There is something worth appreciating in that fact the next time you look at a map. Lake Superior, Lake Michigan, Lake Huron, Lake Erie, Lake Ontario. 5 of the most recognizable shapes on the entire continent are essentially the fingerprints of a glacier pressed into the earth and then filled with its own melted water. Even Niagara Falls, one of the most famous waterfalls on the entire continent, owes its existence to this same story. It sits exactly where Lake Erie drains into Lake Ontario, tumbling over a hard shelf of rock that resisted the glacier's scouring far better than the softer stone surrounding it. Every visitor snapping a photograph at the railing today is in a very real sense standing at the edge of an Ice Age leftover. Have you ever swum in one of the Great Lakes or stood at the railing watching Niagara Falls without ever once thinking about the 2-mile wall of ice that quietly made the whole scene possible? I certainly had not until I started digging into this part of the story myself. And the ice reshaped places you might never expect even far from where it actually reached. Out in what is now Utah, well south of where the great ice sheets themselves ever extended, the Ice Age climate was cooler and considerably wetter than today. Rain and snowmelt that could not evaporate fast enough in that cooler world collected instead in the desert basins of the American West, forming an enormous body of water called Lake Bonneville. At its peak, it very nearly matched the surface area of today's Lake Michigan, standing more than 900 feet deep in places and stretching across nearly 20,000 square miles, an expanse you could not walk the length of in a single week, even walking from sunrise to sunset every single day. All of it sprawled across a landscape that is now some of the driest terrain in the entire country. If you have ever visited Salt Lake City, you've already stood inside the ghost of that lake without necessarily realizing it. Look up at the mountainside surrounding the valley, and you can still make out faint, almost perfectly level shelves cut into the slopes, ancient shorelines left behind as the lake slowly rose and fell over thousands of years. The Great Salt Lake sitting there today, briny and shallow, is really just the last shrunken remnant of something once considerably larger and considerably stranger. It is worth noticing too how differently each of these transformations actually played out. Doggerland disappeared gradually over thousands of patient years. A single unlucky animal at La Brea could vanish in a single afternoon, swallowed by a few feet of sticky asphalt. Lake Bonneville rose and fell repeatedly across tens of thousands of years, leaving a dozen different shorelines stacked up the mountainside like the rings of a tree. Ice Age change, it turns out, never moved at just one single speed. Sometimes it crept forward patient and unhurried. Sometimes it simply reached out and grabbed whatever stood too close. I find something quietly humbling in all of this, honestly. We tend to treat maps as something close to permanent, as though coastlines and lakes and continents were simply handed to us exactly as they are fixed for all time. Doggerland, Sunderland, the Great Lakes, Lake Bonneville, all of it tells a different story. The world you were born into is really just one single frame pulled from an extremely long film, paused at this particular moment for our particular species to walk around in. What all of these transformed landscapes have in common, though, is that none of them stayed empty for long. Wherever dry land opened up, animals moved first, and people followed close behind them, walking across ground that had not existed for their ancestors and would not exist for their descendants either. Doggerland was not simply drowned territory. It was for thousands of years somebody's home and somebody's hunting ground, and quite possibly somebody's entire known world. Sunderland was not just exposed seafloor. It was a bridge that early humans actually used on foot to move deeper into a part of the world no person had ever set eyes on before. And that, I think, is where the physical story we have just walked through turns into a distinctly human one. Because all that reshaped land, all that newly exposed ground stretching between continents, did not just sit there quietly waiting to be admired. People walked across nearly all of it, following herds, following rivers, following nothing more certain than curiosity and hunger, into places their own grandparents would never have believed existed at all. Not every Ice Age journey happened on foot. That might be the part of this story that surprises people most. We have spent a good deal of this journey together talking about forces too large and too slow for any single human life to ever notice: wobbling orbits, grinding ice sheets, a planet quietly rearranging its own furniture over hundreds of thousands of years. This next part of the story moves at a completely different scale, one you can actually picture clearly. A single boat, a single decision, one life choosing to risk everything on a guess about what might be waiting just past the horizon. We've spent a good while now walking across land bridges together, land that appeared because the ocean had nowhere else to put all that water. But somewhere around 60,000 years ago, a group of people did something considerably bolder than simply walking across newly exposed ground. They looked out at open water that never drained away no matter how low the sea level fell, and decided to cross it anyway. The destination was a landmass scientists now call Sahul, a single connected continent joining what is today Australia, New Guinea and Tasmania, fused together by the same falling sea levels we've been talking about throughout this story. Picture the scene for a moment. A small handful of families gathered on a beach somewhere in what is now Indonesia, having already crossed several smaller channels of water just to get even this far. Ahead of them, nothing but open ocean stretching out to a horizon with no land visible anywhere on the other side. Somewhere in that group, somebody had to be the one who decided this particular stretch of water, unlike all the ones behind them, was still worth trying. Getting there from the Southeast Asian mainland, though, was never as simple as walking. Between Sahul and the mainland sat a scattering of islands, and between those islands stretches of ocean that no amount of Ice Age freezing ever fully closed. At least one of those crossings measured close to 60 miles of open water, with nothing but sky and horizon in every direction, once you lost sight of land behind you. Let that sink in for a moment. 60 miles is a seriously demanding open water crossing, even with a compass, a working motor, and a coast guard on standby. These travellers had none of that. What they almost certainly had were simple rafts or dugout canoes paddled or poled by people who'd never seen the destination they were heading toward, based purely on faith that something worth finding lay past the horizon. Researchers who modelled this crossing mathematically found something worth sitting with. If people had simply drifted across on ocean currents by pure accident, the odds of a group actually surviving the trip and successfully founding a lasting population on the other side were remarkably low, well under 5% according to one detailed study, unless dozens of people made repeated attempts across multiple generations. Once you factor in something as simple as picking the right season to depart and paddling with even modest sustained effort toward a chosen direction, rather than drifting passively, those odds climb dramatically. In plain language, the mathematics itself argues that this was not a lucky accident. It was a decision. Somebody looked at the ocean and chose to go. Interestingly, the ancestors of these seafarers appear to have left Africa not long after one of the largest volcanic eruptions of the last 100,000 years, a supervolcano called Toba, in what is now Sumatra, roughly 74,000 years ago. Some researchers have argued that eruption triggered a severe temporary global cooling event that nearly wiped out the human species entirely. Other researchers are considerably more skeptical of that dramatic acclaim, and the debate has not been settled. Either way, the timing sits there as a striking coincidence, whatever its true significance eventually turns out to be. A study published quite recently, drawing on more than 2,000 modern genetic samples from indigenous communities across Australia, New Guinea, and the surrounding islands, traced this journey back to roughly 60,000 years ago, arriving by at least two separate routes rather than one single crossing. One path apparently came through what is now the island of New Guinea in the north. The other pushed further south through the chain of islands leading toward Timor, before making that final unavoidable open water crossing into northern Australia. Two separate groups taking two separate gambles, arriving at roughly the same improbable destination. Some researchers still argue for a somewhat later date closer to 50,000 years, and that particular disagreement remains honestly unresolved. But even taking the more conservative estimate, this stands as among the earliest solid evidence of deliberate seafaring found anywhere on the planet by a wide margin. Long before the pyramids, long before writing, long before agriculture itself, someone built a boat capable of crossing open ocean and trusted it enough to climb aboard with their family. Have you ever stood at the edge of open water and tried to imagine what it would take to simply keep going with no idea? What if anything waited on the other side? I find that image sits with me longer than almost anything else in this entire story. It raises a truly interesting question about human nature if you sit with it a while longer. Every migration we have discussed in this story so far involved walking onto land that was at the very least visible and reachable underfoot. This one did not. Whoever pushed that first raft into open water was choosing uncertainty over the relatively known world behind them, based on nothing more concrete than intuition, maybe rumour passed along the coast, maybe simple restlessness. That particular impulse, choosing the unknown over the familiar purely on a hunch that something better might be waiting, feels remarkably, almost uncomfortably familiar even now. And what awaited them on the other side was nothing like the world they had left behind. Sahul was home to animals found nowhere else on the planet. Giant flightless birds taller than a grown man. Kangaroos built the size of the very rafts that had carried these travellers there, and marsupial predators built along completely different evolutionary lines than anything roaming Asia or Africa. Whatever these first arrivals expected to find past the horizon, it almost certainly was not that. Now let us swing back around to the more familiar kind of Ice Age journey, the one that unfolded almost entirely on solid ground on the opposite side of the planet. We touched briefly on the Bering Land Bridge earlier in this story, that wide stretch of exposed seafloor connecting Siberia to Alaska. For a long time, the standard assumption was that people simply walked across it and kept moving a fairly quick continuous march straight down into the heart of North and South America. Genetic evidence collected over the past 2 decades tells a considerably more patient story. Researchers studying mitochondrial DNA, the genetic material passed down almost unchanged from mother to child across generations, noticed something curious buried in the family tree of Native American populations. A whole cluster of genetic markers appeared to have formed in isolation, cut off from their closest relatives in Asia for a stretch of several thousand years, before finally spreading rapidly across 2 entire continents. Scientists call this idea the Beringian standstill hypothesis, and the picture it paints is remarkable. Rather than a brief crossing, ancestors of nearly every indigenous population in the Americas may have spent somewhere close to 10,000 years, some estimates run even longer, essentially trapped and settled on the Bering Land Bridge itself, hemmed in by walls of glacial ice to the east that would not open for millennia. The idea first gained real traction in 2007, when a team of geneticists sampling mitochondrial DNA from more than 600 Native American volunteers found mutation patterns that fit this exact scenario, evidence of a founding population that had clearly spent an extended stretch of isolation before its descendants ever set foot south of the ice. That raises an obvious question. What were people actually doing there for 10,000 years? If you had to guess before I tell you, how long do you think a group of people could stay isolated from their nearest relatives before showing up as a distinct, measurable population in their own descendants' genes thousands of years later? If your guess landed somewhere in the thousands of years, you would fit right in with what the genetic evidence actually shows. Surviving mostly and rather well, it turns out. Researchers studying ancient beetle remains preserved in sediment from that region. Tiny insects that only tolerate very specific temperature ranges have used them almost like miniature thermometers, and the resulting climate picture is surprising. Parts of Beringia, sheltered by mountains and warmed slightly by the nearby ocean, may have stayed noticeably more hospitable than the harsh Siberian steppe these travellers had left behind. Shrubby vegetation, usable firewood, and enough game to support real lasting communities. Not a bridge people rushed across in a hurry. More like a strange isolated homeland hidden between two continents that simply happened to disappear beneath the waves several thousand years later. Picture raising children there generation after generation in a place that appears on no map made before or after it existed. Learning the moods of the local rivers, the patterns of the local herds, the particular rhythm of light through a long polar winter, all while your distant relatives back in Siberia lived out entirely separate lives, never knowing you were there, and you never fully knowing what had become of them either. Once the ice sheets finally began retreating and a path south truly opened, the descendants of that isolated Beringian population spread with startling speed, reaching the southern tip of South America within what looks on a map of deep time like the blink of an eye. Exactly how fast and exactly which route they took happens to be one of the liveliest ongoing arguments in modern archaeology, and I think it is worth being honest with you about that rather than pretending the matter is closed. For decades, the accepted story centered on a culture named Clovis, identified by finely crafted fluted spear points, first discovered near a small town in New Mexico, dated to roughly 13,000 years ago. Then, starting in the 1970s, a site in southern Chile called Monteverde began turning up wooden hut remains tent stakes, even preserved footprints that appeared to be older than Clovis by well over 1,000 years. It took nearly 20 years of at times honestly bitter academic argument before most of the field came around to accepting an older pre-Clovis timeline, and fittingly given everything else we have discussed about how real science works, even that dating remains under fresh scrutiny today, with researchers actively re-examining the exact sediment layers involved as recently as this year. Other sites in Oregon, Texas, and Florida now support the broader pre-Clovis picture, regardless of how that particular argument eventually settles. One of those sites, a set of caves in Oregon called Paisley Caves, produced something almost stranger than stone tools, ancient human waste perfectly preserved in dry cave sediment, containing DNA old enough to predate Clovis by more than 1,000 years. Not exactly the most glamorous kind of archaeological treasure, but every bit as convincing as a spear point and considerably harder to argue with. I actually find that ongoing uncertainty kind of wonderful, if I am honest with you. It means the story of how your own continent was first settled by human beings is not a finished chapter sitting quietly in a textbook. It is still actively being written, argument by argument, sediment layer by sediment layer, by researchers working right now. Here is something worth pausing on, comparing these two great migrations side by side. The journey to Sahul was audacious and comparatively sudden, a small group choosing to gamble everything on a single ocean, crossing toward an unknown horizon. The journey into the Americas was the opposite in almost every way, a slow, patient, multi-generational waiting game. An entire population essentially paused on a narrow strip of land for thousands of years before conditions finally allowed them to continue. Boldness in one direction, patience in the other. Both strategies remarkably worked. I think that says something worth sitting with about our species more broadly. Faced with a world being constantly rearranged by forces nobody around them could see or explain, Ice Age humans did not respond with just one strategy. Some pushed forward the moment an opportunity appeared, no matter how narrow or terrifying. Others waited sometimes for thousands of years until the moment was actually right. Both approaches got people to entirely new continents that no human being had ever set foot on before. It is not so different in a way from choices we all still make today, just at a smaller, quieter scale. Some people leap the moment an opportunity shows up uncertain, but unwilling to let it slip past them. Others hold steady, gathering strength and information, waiting for the exact right moment before finally moving. Neither instinct is wrong. Both, it turns out, have carried our species remarkably far. Doggerland, Sunderland, Beringia, Sahul. Every one of these vanished landscapes we've walked through together carried people across it on foot or by boat, chasing herds, chasing curiosity, chasing whatever unnamed pull sends any of us looking for what lies over the next hill or past the next stretch of open water. That instinct, it turns out, is a great deal older than any of us usually give it credit for. Every person today planning a move to a new city or booking a flight to somewhere they have never once set foot carries a small, quiet echo of that exact same impulse, whether they realize it or not. But surviving a world that offered new land to walk across was only half the challenge these early travelers faced. Ice Age climate did not simply retreat quietly once it started warming up. Every so often it turned around and struck back hard and fast with almost no warning at all. That sudden reversal and what it can teach us about how fragile even a warming world can still be is exactly where we are headed next. Sometimes the most important scientific discoveries begin with something almost embarrassingly small. In this particular case, it was a flower. In the early 1900s, researchers digging through old bog sediment in Sweden and Denmark kept finding the same odd thing layer after layer. Fossilized pollen from a small, pale, cold-loving plant called Drias octopetala, sometimes known as mountain avens, a flower that only grows where conditions are truly harsh. What made it strange was where that pollen sat in the sediment. Beneath it, pollen from warm climate forests. Above it, pollen from warm climate forests again. But right in the middle, sandwiched between two clearly warm periods, a sudden, unmistakable layer of cold, loving flower pollen, as though winter had crashed an already finished party and stayed for 1,000 years before finally leaving. It took decades for scientists to fully piece together what that pollen was actually telling them. A single sediment core showing the pattern might look like a local oddity, nothing more. It was only once the same strange layer started turning up in lake beds and bogs scattered across an entire continent that anyone realized they were looking at something considerably bigger than one flower having a good decade. Scientists eventually named the whole strange episode after that flower, the Younger Dryas, and once you actually understand what it represents, it becomes one of the more unsettling chapters in this entire story, because it proves something the rest of this documentary has mostly avoided saying out loud until now. Warming is not always a straight, gentle line. Picture where we left off a little earlier in this journey. The ice sheets are retreating, sea levels are climbing, Doggerland and Sunderland are shrinking year by year, and the descendants of those Beringian travellers are spreading rapidly across two entire continents. Life in a broad sense is getting easier. The worst of the Ice Age truly appears to be behind everyone. Warm, loving trees are creeping back into landscapes that had been locked in tundra for millennia. Herds are shifting their grazing grounds northward, chasing the retreating cold. For the people living through it, the pattern must have looked like a simple, permanent one-way trip out of the deep freeze. Then, roughly 12,900 years ago, without warning, the warming simply stopped. And in some places it violently reversed. Here is the part that still catches me off guard every time I think about it properly. This was not a slow slide back into the cold, the way the ice ages themselves crept in over tens of thousands of patient years, the kind of pace we've spent most of this story getting used to. Ice cores drilled in Greenland show temperatures in some regions dropping several degrees within mere decades, a geological eye blink compared to everything else we've discussed together. In Greenland itself, researchers estimate temperatures fell by something close to 18 degrees Fahrenheit. Across much of Europe, the drop measured somewhere between 4 and 11 degrees. Even in parts of North America far from the immediate epicenter, average temperatures cooled by roughly 5 degrees. Numbers like that arriving within a single human lifetime rather than over millennia are exactly the kind of shift the rest of this story has trained you to expect only across tens of thousands of years. Large parts of the Northern Hemisphere, having spent centuries thawing out, found themselves shoved back toward conditions close to full glacial cold and stayed there for roughly the next 1,000 years. Can you imagine living through something like that? Not knowing you were living through a named catalogued climate event, obviously just knowing that the mild years your parents remembered seemed to be ending, and the world outside your door kept getting colder year after year with no obvious reason why. So what actually caused it? This is where the story turns into something close to a detective case, because the leading explanation involves water taking a very unexpected detour. As the great ice sheets over North America melted, they released almost unimaginable volumes of fresh water, much of it pooling into a lake so enormous it briefly ranked among the largest bodies of fresh water to ever exist on the planet. Scientists call it Lake Agassiz, and at some point its icy dam gave way. That flood of fresh cold water surged north out into the Arctic and the North Atlantic Ocean, right into the middle of one of the most important circulation systems on the entire planet. Think of the ocean's deep currents as a kind of enormous slow conveyor belt carrying warm water up from the tropics toward the North Atlantic, releasing heat into the air, along the way warming Europe and eastern North America far more than their latitude alone would normally allow. That belt depends on salty, dense water sinking in the far north to keep the whole system turning over. Flood that same region with a sudden surge of fresh light meltwater, and the sinking slows or stalls out completely. The belt stutters. The heat delivery that had been quietly warming half a hemisphere simply stops arriving. It is a little like a household furnace that runs on fuel delivered by truck every week. Flood the delivery road with enough water, and it hardly matters how well the furnace itself still works. The fuel simply cannot get through anymore, and the house goes cold not because the furnace broke but because the road leading to it did. That is the leading explanation, and it has decades of solid evidence behind it. I want to be honest with you though, because there is a second, considerably stranger idea that keeps resurfacing in the scientific conversation, and it deserves a fair mention rather than a dismissive footnote. A smaller group of researchers has spent years arguing that a comet or a swarm of comet fragments struck the Earth right around this same window of time, kicking enough debris and dust into the atmosphere to trigger sudden cooling on its own. Just last year, a research team reported finding platinum and glassy heat, formed debris in ocean floor sediment from Baffin Bay, the kind of material usually associated with a genuine impact event. Most researchers in the field remain unconvinced, and the meltwater explanation still holds the stronger position by a fair margin. But the debate has not gone away, and I think it says something honest about this whole field that a wonderfully wild-sounding idea keeps earning just enough new evidence to stay in the conversation. If you had to bet on it yourself, which explanation would you lean toward meltwater quietly stalling an ocean current, or something considerably more dramatic falling out of the sky? I will admit unlikely, as the comet idea might be some small part of me always roots for the more dramatic option. Whatever ultimately triggered it, the human cost of the Younger Dryas was real. Communities across Europe that had been expanding into newly thawed territory found themselves retreating again abandoning northern settlements as the cold pushed back in. Populations in some regions appear to have shrunk considerably during this stretch, forced into smaller, more resilient pockets of territory. Archaeological sites across parts of northern and western Europe that show clear signs of steady occupation just before the Younger Dryas often go quiet in the layers, dating to the cold snap itself, abandoned presumably as people retreated toward more sheltered, resource-rich pockets of land further south. It is a pattern archaeologists have learned to recognize across many different collapses throughout history. When conditions turn hostile enough, people rarely simply vanish. They concentrate, and they wait. But here is where the story takes a truly surprising turn, one I think is worth sitting with for a moment, because it might be the most quietly important chapter in this entire Ice Age saga, in a region we now call the Levant, roughly where modern-day Israel, Jordan and Syria meet a group known to archaeologists as the Natufian culture, had spent the centuries before the Younger Dryas doing something unusual for hunter-gatherers. They were settling down, building semi-permanent villages, grinding wild cereal grain into flour using carved stone mortars, well enough that archaeologists working at a site called Shubayqeh in modern Jordan found the remains of something startlingly familiar: bread baked from wild grain roughly 14,400 years old, predating full-scale farming by around 4,000 years. People were making something close to bread long before anyone had actually invented agriculture to grow the grain for it. At another site called Ain Malahar in what is now northern Israel, archaeologists have uncovered the remains of an entire Natufian village, complete with round stone houses, storage pits dug for keeping surplus grain safe through lean seasons, and burial sites suggesting a settled community with real lasting roots in one place. These were not people camping temporarily and moving on. They were building something close to permanent life centuries before anyone had officially invented farming to support it. Then the Younger Dryas hit, and the wild cereal fields these communities had come to depend on began to fail under the sudden drought and cold. Many researchers believe, and this remains honestly debated rather than settled fact, that this specific stress is what pushed some Natufian communities to stop simply gathering wild grain and start deliberately planting it instead, tending it, protecting it, guiding its growth on purpose for the first time. Not yet full agriculture in the way we would recognize it today, but something sitting right on that threshold, a direct, desperate response to a food source that could no longer be trusted to simply show up on its own. Have you ever noticed how some of the most important shifts in your own life happened not during comfortable, easy stretches, but during the exact moments things stopped working the old way? That pattern, it turns out, is a great deal older than any of us. Some archaeologists today push back a little on how tidy that story sounds, and fairly so. Full-scale farming villages really only bloomed once the Younger Dryas finally ended, and stable warmth returned for good, which suggests the crisis alone was not quite sufficient on its own. But even the more cautious version of this story keeps one thing intact. A brutal 1,000-year cold snap arriving without warning, in the middle of what should have been a straightforward recovery, appears to have nudged at least some of our ancestors right up to the edge of inventing farming. One of the most consequential inventions in human history may owe at least part of its origin to a climate whiplash nobody saw coming and nobody could explain at the time, and then just as abruptly as it began, it ended. Roughly 11,700 years ago, the deep freeze broke. Greenland ice cores suggest local temperatures climbed by something close to 18 degrees Fahrenheit in as little as a single decade, one of the fastest climate shifts ever recorded anywhere in the geological record. The world that emerged from that final thaw is, broadly speaking, the same stable, warm world human civilization has called home ever since. And here is a detail that rarely makes it into the popular retelling of this story. The Younger Dryas was not even the only abrupt cold snap during this general stretch of time. Ice cores show an earlier, shorter reversal, sometimes called the Older Dryas, interrupting the warming trend a few centuries before the main event. The end of the last ice age, it turns out, was less like flipping a single switch from cold straight to warm, and more like a light fixture with a loose connection flickering several times before it finally properly turned on for good. I think what this whole episode leaves me with more than any single fact inside it is a kind of respectful caution about how we picture climate change in general ice age or otherwise. It is tempting to imagine warming and cooling as smooth, obedient lines on a graph, patiently rising or falling exactly the way the orbital mathematics predicts. The Younger Dryas is a reminder that real climate systems have their own internal moods, their own thresholds and tipping points, and that a world quietly warming for 1,000 years can still, without much warning, slam the door shut again for a while. It also leaves me with something a little more hopeful, if I'm honest with you. Even after 1,000 years locked back in the cold, people did not simply vanish or give up. They adapted. Some retreated. Some remarkably used that exact pressure to invent something entirely new. Have you ever gone through a stretch of your own life that felt like it was actively working against you, only to look back later and realize that exact pressure pushed you towards something you would never have found? Otherwise, civilizations, it turns out, are not so different from people in that particular respect. There is a common misconception hiding underneath all of this that I think is worth clearing up before we move any further, because it comes up constantly whenever people picture ice ages in their heads. Most of us imagine sudden climate collapse looking like something out of a disaster film, an entire ocean freezing solid within hours, city streets buried under snow before rush hour even ends, walls of frost chasing people down open streets. It makes for a thrilling couple of hours at the movies. It has almost nothing in common with how an actual ice age, even one arriving as fast as the Younger Dryas, actually behaves. Even the Younger Dryas, one of the fastest climate reversals ever recorded on this planet, needed the better part of a human generation to fully take hold, not an afternoon. That gap between what popular imagination assumes about ice ages and what the actual evidence shows turns out to be filled with quite a few other stubborn myths as well. Some of them repeated so often that most people simply accept them as settled fact. Untangling exactly which parts of the Ice Age story are true and which ones are just Hollywood taking a few very understandable liberties feels like exactly the right place for us to go next. Let me ask you something honestly before we go any further. If I said the words Ice Age to you right now and asked you to picture it, what actually shows up in your head? Go on, actually picture it for a second before reading any further. I will wait. If you are anything like most people, I would guess it involves an entire ocean freezing solid. Within a matter of hours, city streets buried under snow before anyone can even get home from work. Maybe a wall of frost visibly chasing someone down a street. That image is not really your fault. It comes from a wonderfully entertaining movie, one that took a real fascinating piece of science and quite deliberately compressed it from centuries into an afternoon for the sake of a good thrill ride. Here is the honest physics of it, though. Oceans hold an almost unbelievable amount of heat, so much that even a truly severe disruption to global circulation, the kind we spent our last chapter discussing together, still takes years to decades to meaningfully shift temperatures across an entire hemisphere, not hours. The atmosphere moves fast. The ocean, which actually holds the vast majority of the planet's stored heat, moves slow, and it is the ocean that ultimately sets the pace for how quickly climate can truly change. Even the fastest, most dramatic cold snap in the entire geological record needed the better part of a human generation to properly take hold. Hollywood needed about 3 days, because a 3-day countdown makes for better ticket sales than a 3-decade one. I do not blame the storytelling instinct there, honestly. I make my living telling you stories too. I just think it is worth knowing where the line between drama and reality actually sits. Think back for a moment to that 1,000-year cold snap we just spent an entire chapter walking through together. Even that event, one of the fastest, most violent climate reversals anywhere in the geological record, needed decades to fully take hold at its very fastest points, and roughly 1,000 years to run its full course from start to finish. If the single quickest climate shift scientists have ever documented in ice cores still moved at that pace, an ocean freezing over a long weekend was never a realistic possibility in the first place, no matter how good it looks on a movie poster. Now here is a myth that runs in the opposite direction, and it might surprise you even more. A lot of people picture an ice age as the entire planet frozen over pole to pole, one unbroken sheet of white from the Arctic to the equator. It is an understandable image, but it is simply not what happened during any of the ice ages we have spent this story exploring together. Even at the absolute coldest point of the last glaciation, roughly 30% of Earth's land sat under ice. That leaves 70% that did not. Most of the tropics stayed green, or at least brown and dusty rather than white. Central Africa, most of South America, huge stretches of Southeast Asia, none of it disappeared under a glacier. In fact, some regions actually became drier and dustier during the ice ages rather than colder and icier, since so much of the planet's moisture ended up locked away inside growing ice sheets, that rainfall patterns shifted dramatically elsewhere. Large stretches of what is now the Sahara, ironically enough, went through periods of being even more parched during the coldest glacial maximums than the desert we know today. Here is where it gets truly strange, though, because a true planet swallowing deep freeze did actually happen once, just not during any ice age you've ever heard mentioned in a school textbook, and not anywhere close to recently. Roughly 700 million years ago, during a stretch of time geologists call the Cryogenian period, something happened to this planet that makes every ice age in our story so far look almost gentle by comparison. Ice sheets did not just creep down from the poles. They kept going past the point where any modern ice age has ever reached, all the way to the equator. Geologists have found rock formations formed unmistakably by glaciers sitting in regions that sat directly on the equator at the time, confirmed using the magnetic signatures locked inside the stone itself. For a stretch, lasting somewhere between several 100,000 and several million years, depending on which particular event you're looking at, this entire planet may have truly resembled a single frozen white marble hanging in space. Scientists call the idea snowball Earth, and it is worth sitting with how different the underlying cause actually was compared to everything else we've discussed together in this story. This had nothing to do with Milankovitch's 3 orbital wobbles. It came down to simple runaway physics. Once ice cover crosses a certain threshold, it reflects so much sunlight back into space that the planet keeps cooling, which grows more ice, which reflects even more sunlight. A feedback loop with no natural brake pedal once it truly gets going. Getting out of it apparently required an entirely different kind of rescue. With almost the whole planet sealed under ice, the usual processes that pull carbon dioxide out of the air weathering rock, and growing plants essentially shut down completely. Volcanoes, though, kept right on erupting underneath all that ice, slowly building up carbon dioxide in the atmosphere for millions of years, until the greenhouse effect finally grew strong enough to break the ice's grip and thaw the entire planet back out. Some researchers argue the freeze may not have been quite so absolute everywhere, with a band of thinner, slushier ice near the equator, rather than solid rock hard ice from pole to pole, an idea nicknamed rather charmingly slush ball Earth. Either way, life did not vanish completely. Tiny pockets of liquid water sheltered near volcanic vents, or beneath thin patches of ice, appear to have kept simple microbial life alive through the entire ordeal waiting out millions of years of near total darkness and cold for their moment to bloom again. Have you ever wondered what the very first creature to see open water again after millions of years locked away under ice might have felt? If it could feel anything at all, I think about that more than I probably should. Have you ever tried to picture what it would actually look like standing on a beach at the equator, on a planet completely sealed in ice from pole to pole? I have tried more than once, and I still cannot quite make the image hold together in my head. So to be clear about the difference, what we've spent most of this story exploring cycles driven by Milankovitch's 3 orbital wobbles, covering somewhere around 30% of the planet's land at their peak, is a real ice age. Snowball Earth 700 million years ago, an entirely separate, far more extreme event driven by runaway feedback rather than orbital timing, covering close to the entire surface of the planet, is something else altogether. Same general term, 2 wildly different scales of catastrophe. Let us swing to a much smaller myth now, one that trips people up for the opposite reason. If Snowball Earth is the myth of underestimating the scale of a true ice age, this next one is the myth of overestimating a much smaller event by giving it far too grand a name. You may have heard the phrase Little Ice Age before, maybe attached to old paintings of frozen European rivers or stories about ice skating parties on the River Thames in London. It is a real historical period running roughly from the 12 or 1300s through the 1800s, and it absolutely did bring real documented hardship. Winters grew harsh enough that the Thames froze solid, often enough to support proper festivals directly on the ice, complete with food stalls, games, and even printing presses set up to sell souvenirs to people walking across the frozen river. Historical accounts describe entire makeshift streets of vendors springing up on the ice selling roasted meat, hot drinks and trinkets, with reports of a whole ox being roasted directly on the frozen surface of the river during some of the harshest years. It must have felt less like enduring a brutal winter, and more like an entire city deciding once every few years to throw an impromptu festival on top of a genuine hazard. Crop failures during the coldest stretches contributed to real famines and genuine social upheaval across parts of Europe. Here is the myth, though. None of that makes the Little Ice Age an actual ice age in the sense we've been using that word throughout this entire story. Temperatures during that period dropped by somewhere around 1 or 2 degrees Celsius below average for a few centuries in specific regions, mostly across the northern hemisphere. Compare that to the 10 or more degrees of cooling, and the mile deep ice sheets involved in an actual glacial period, and the scale difference becomes obvious immediately. The causes were different too. Rather than orbital wobbles playing out over tens of thousands of years, current research points mainly toward a cluster of large volcanic eruptions, dimming sunlight with ash and sulfur particles for years at a stretch, with reduced solar activity likely playing a smaller supporting role than popular retellings usually give it credit for. It helps to see the contrast on either side of it too. Right before the Little Ice Age settled in Europe had been enjoying a stretch called the Medieval Warm Period, mild enough that Norse settlers established farming colonies in Greenland, and vineyards in southern England produced wine good enough to export abroad. When the cold finally arrived, those same Greenland colonies withered away entirely within a couple of centuries, and English vineyards mostly disappeared for hundreds of years afterward. A swing of only a degree or two, in other words, was still more than enough to redraw the map of what people could grow and where they could reasonably expect to survive. It is truly fascinating, if you sit with it, how a real well-documented cold snap that reshaped European history for centuries still counts as barely a shiver compared to the events we've spent the rest of this story discussing. One more myth, and then I promise we will move forward again. Some people assume there has only ever been one ice age in the entire history of this planet, the one filled with mammoths and stone tools and painted cave walls that most of us grew up picturing. If you had guessed a number before I told you how many separate ice ages would you have assumed this planet has actually lived through? Most people I ask land somewhere between 1 and 2. The real number is more humbling. In reality, geologists count at least 5 separate major ice ages across Earth's long history, each one triggered by a completely different combination of causes. The very first, called the Huronian, happened somewhere around 2.4 billion years ago, likely triggered when early photosynthetic microbes flooded the atmosphere with oxygen, for the first time wiping out most of the methane that had been keeping the planet warm. In between that event and our own, an ice age called the Andean-Saharan gripped the planet roughly 450 million years ago, and it coincided with one of the largest mass extinctions this planet has ever recorded, wiping out a majority of all species alive at the time. Whole branches of ancient sea life trilobites and early shelled creatures with no modern equivalent vanished as sea levels collapsed and ocean chemistry turned hostile. Much later, an ice age called the Karoo gripped the planet for roughly 100 million years, partly because early forests were pulling so much carbon dioxide out of the air that the whole atmosphere cooled down. That particular ice age, strangely enough, also happened to coincide with dragonflies boasting wingspans over 2 feet wide, and millipede relatives stretching longer than a grown adult because all that extra oxygen in the air let insects grow to almost alarming sizes. The ice age with the mammoths, the one this entire documentary has been walking you through, is really just the most recent chapter in a much longer, much stranger book. What strikes me most, laying all of these myths out side by side like this, is how consistently reality turns out to be both less cinematic and considerably more interesting than the popular version. No instant flash freezing, no single uniform white planet except for that one truly bizarre stretch 700 million years ago. No single event called the Ice Age at all, but rather 5 entirely different climate catastrophes separated by hundreds of millions of years and completely different causes, all filed under the same casual misleading label. It makes me wonder how many other big confident-sounding words we all use every day are secretly hiding this same kind of mess underneath them. Several entirely different things quietly squeezed into a single convenient label, because nobody bothered to sort them out properly. And here is a thought worth sitting with as we head into the next part of this story. If a period as brief and modest as the Little Ice Age still managed to freeze rivers solid and topple harvests across an entire continent, and if the Ice Age most of us picture in our heads only ever covered 1/3 of the planet's land, then the actual current relationship between our modern world and the broader Quaternary Ice Age we technically still belong to deserves a much closer look than most people ever give it. Because here is the part that tends to catch people completely off guard. Geologically speaking, the Ice Age never actually ended. Let me explain exactly what that means, because it is not just a clever turn of phrase to keep you listening. Geologists have a fairly simple, almost stubbornly literal way of deciding whether a planet counts as being in an ice age. It has nothing to do with how cold it feels outside your window on any given afternoon. The actual rule is this: if permanent ice sheets exist anywhere on the planet year-round at either pole, that planet is by definition living through an ice age. Not a metaphorical one, an actual technical, geologically accurate one. By that same standard, most of the last few 100 million years of Earth's history would not have counted as an ice age at all. For long, almost unimaginable stretches, this planet carried no permanent ice anywhere, not even at the poles. Crocodile relatives swam in polar waters. Forests grew within a few hundred miles of the South Pole. A permanently ice-free planet, it turns out, is not some strange, unlikely fluke in Earth's story. Historically speaking, it has actually been closer to the norm. Now go ahead and picture Antarctica for a moment. Still there, still covered in ice several miles thick in places. Picture Greenland. Also still there, also still buried under a truly enormous ice sheet of its own. by the plain, unglamorous definition geologists actually use that alone settles the question. We have never left the Ice Age this entire documentary has been walking you through. We're living inside it right now tonight as you listen to this. Does that surprise you at all? I have to admit, the first time I properly understood this myself, it took a good few minutes to actually sink in. An ice age was always supposed to be something that happened to other people, sealed inside a black and white textbook photograph, not something quietly wrapped around the exact evening you happen to be having right now. What we've actually been calling an ice age this whole time, more precisely, is the Quaternary glaciation, a stretch of roughly 2.5 million years defined by exactly the kind of back-and-forth rhythm Milutin Milankovitch spent his life trying to explain. Long, brutal glacial periods when ice sheets crawl down over entire continents, followed by shorter, milder stretches called interglacials, when the ice retreats and the world briefly warms back up. We are right now sitting inside one of those milder stretches. Scientists gave it a name, the Holocene, a word borrowed from Greek that roughly translates to entirely recent, a slightly self-important label for what amounts to a fairly brief blink in this planet's much longer story, though an understandable one given that everyone who ever coined a word for it was of course living entirely inside that same blink. Here is the number worth sitting with for a moment. The Holocene began roughly 11,700 years ago, right as the last deep freeze of the Ice Age finally decisively broke. Every single thing you have ever personally associated with human civilization, the first cities, the first written words, the pyramids, every empire, every war, every book, every single technology you have ever used in your entire life, all of it happened inside that one narrow window. 11,700 years out of a 2.5 million year ice age. If you compressed the entire Quaternary glaciation down into a single 24-hour day, all of recorded human civilization would fit inside the final 0.6 of 1 second before midnight. Every pyramid ever built, every war ever fought, every single word anyone has ever spoken or written down, crammed into a sliver of time so thin it would be remarkably difficult to notice on a clock face, if the rest of the Ice Age's 2.5 million years were the only thing you were watching for. Have you ever stopped to consider that literally everything you know, every name, every language, every border on every map you've ever looked at exists entirely within a climatic eye blink? A brief pause the planet happened to take between one glacial period and the next. It gets stranger the closer you look too, because this is not even the first time the planet has taken a pause quite like this one. Roughly 130,000 years ago, well before modern humans had spread very far beyond Africa, an earlier interglacial settled over the planet. Scientists call it the Eemian. And here is the detail that tends to catch people off guard. The Eemian was not just similar to the world we know today. In several ways it was noticeably warmer. Global temperatures ran somewhere around 1 to 2 degrees Celsius above where they sit today. Sea level stood at least 6 meters higher in places closer to 9, and in what is now the Thames River Valley in England of all places, hippopotamuses waded through the water alongside elephants that no longer exist anywhere on Earth. Here is the part that tends to truly surprise most people once they hear it properly. Carbon dioxide levels during the Eemian sat at roughly 280 parts per million, noticeably lower than what fills the atmosphere today. The extra warmth back then had nothing to do with greenhouse gases at all. It came entirely from the same 3 orbital wobbles we spent so much time on, earlier lined up in a way that pushed extra summer sunlight onto the high northern latitudes, precisely the mechanism Milankovitch spent 4 years in Budapest trying to describe. I want you to actually sit with that image for a second. Hippos in England, not in some distant tropical past measured in tens of millions of years, A mere 130,000 years ago, well within the time frame modern humans already existed as a species. Here is what makes that comparison honestly useful rather than just a fun trivia fact though. The Eemian eventually ended. Slowly at first, then with real speed, ice caps began reforming in Scandinavia. Temperatures dropped, and within a few thousand years the planet had slid back into a full glacial period. Some records suggest the shift from warm hippo-filled rivers to genuine glacial conditions took only a handful of centuries to become unmistakable, a reminder that even a stable-seeming pause can tip toward its ending faster than anyone standing in the middle of it would expect. Interglacials, in other words, are not a permanent state a planet simply arrives at and keeps. They are a phase, a pause, and every previous pause, just like the one we are living in right now, has eventually come to an end. The Eemian was not even the only one either. Ice cores and ocean sediment stretch that same record back across the full 800,000 years we discussed earlier in this story, revealing roughly 8 or 9 separate interglacial pauses, each one slightly different in length and intensity scattered across that entire span, like rest stops along an extremely long highway. So does that mean our own pause is due to end any moment now? This is where the story turns truly interesting, and where I want to circle back to something I mentioned earlier in this documentary, and promise to properly explain later. Remember when we talked about Earth's orbit sitting in an unusually circular phase right now, and the planet's axial tilt drifting toward the gentler end of its range rather than the more extreme one? That combination is not a small detail. Researchers studying the precise rhythm of past interglacials have found that the specific alignment of Earth's orbit today closely resembles the conditions behind a few unusually long interglacials scattered throughout the Ice Age's deep past stretches that lasted considerably longer than the typical 10 or 20,000 year pause. Under natural conditions alone with no human influence whatsoever, several careful studies published in the last few years estimate the next glacial period would not be expected to begin for at least another 50,000 years, an unusually long reprieve by the standards of this entire 2.5 million year cycle. A team of researchers at the Potsdam Institute for Climate Impact Research first laid out this particular calculation in detail back in 2016, and a separate, more recent analysis published in the journal Science examining 8 full glacial cycles with remarkable precision arrived at a strikingly similar conclusion just last year. And then on top of that already unusual natural stability, humanity has added something no previous interglacial ever had to contend with: a rapid, deliberate injection of carbon dioxide into the atmosphere. Researchers modelling how that extra carbon dioxide interacts with the planet's orbital rhythm have found that it likely pushes the next glacial inception even further out, delaying it by tens of thousands of years beyond what natural conditions alone would have produced. Estimates vary considerably depending on exactly how much carbon humanity ultimately releases, with some studies suggesting a delay of only a further 50,000 years, and others based on higher emission scenarios suggesting the next ice age could be postponed for several 100,000 years or theoretically longer still. Picture what that kind of delay might actually mean if you stretch your imagination out far enough. Coastlines shaped roughly as we already know them for a span of time considerably longer than the entire recorded history of agriculture. Every civilization that has ever risen and fallen stacked end to end and still not filling the gap. Or alternatively, picture almost nothing changing hands for 500,000 years, a span so long that whatever species eventually inherits this planet by the end of it might carry only the faintest, most garbled legend of anyone who ever called themselves human. I think it is worth sitting with the strange, slightly uncomfortable shape of that idea for a moment. For the entire span of this documentary, we have been telling a story about slow, patient orbital rhythms, indifferent to anything happening on the surface of the planet, ticking along on their own schedule regardless of who or what lived through them. And now for what appears to be the first time in the entire 2.5 million year history of this ice age, a single species has become relevant to that timeline. Not in control of the orbital wobbles themselves, obviously. Those keep turning exactly as they always have. But relevant for the first time to how those wobbles actually translate into ice on the ground. I am not going to use this moment to tell you what to think about that one way or another. Reasonable, well-informed people disagree about plenty of the finer details, and this has been a documentary about deep time and ancient ice, not a platform for me to lecture you about the present moment. But the narrow specific fact itself that human activity now appears to be measurably influencing the timing of Earth's next glacial cycle sits there in the research regardless of where any of us personally land on the wider debate. The underlying narrower scientific fact sits there quietly on its own, separate from any of the louder arguments built on top of it. A civilization that emerged entirely within one exceptionally brief, exceptionally mild pause in an ancient ongoing cycle has in a few short centuries started nudging the timing of that cycle itself. Let me leave you with one more way of looking at all this, because I think it reframes the entire scale of the story we've been telling together tonight. Every civilization you have ever studied in a history book, every ancient ruin you might visit on vacation, every language, every religion, every single human being who has ever lived and died existed entirely within a climatic exception, a brief, unusually generous stretch of stability carved out of a much colder, much harsher 2.5 million year norm. We did not build civilization despite the Ice Age. We built it entirely inside one of its rare quiet exhales during the narrow window when the planet happened to be holding its breath. Have you ever thought about your own life, your own ordinary Tuesday afternoon, as something quietly nested inside a 2.5 million year rhythm? Most of human history never had the tools to even notice. I find that thought oddly calming, more than unsettling if I am honest with you. It puts a lot of the smaller everyday noise into a very different kind of perspective. Whatever is sitting on your own list of worries tonight, it is happening inside one of the more forgiving windows this planet has offered any species in 2.5 million years. That does not make the worries any less real. It just places them inside a slightly wider room than we usually remember to picture. And that brings us finally close to the end of this particular story, though. Not quite all the way there yet. We have walked through prisoners doing mathematics in wartime libraries, boulders sitting in the wrong country ice cores pulled from the coldest place on the planet, entire vanished continents, a sudden 1,000-year freeze, and a long list of stubborn myths worth correcting. What remains is the simplest and maybe the most important part of all. What all of this is actually supposed to mean to you tonight, lying there listening at the end of a long day on an ordinary Tuesday inside a climatic exception that made your entire existence possible in the first place. So let me try to answer that properly now that we are finally here at the end of a very long night together. Close your eyes for a moment if they are not closed already and go back to where we began. 2 miles of ice stretching out under a pale, colourless sky. A herd of mammoths sweeping their tusks through the snow to find grass buried underneath. A small circle of huts built from the bones of animals nobody alive today has ever seen in person, warmed by a single fire with a family inside telling a story they've probably told 100 times before. Do you remember the silence of that place? No engines, no distant traffic, nothing but the faint hiss of drifting snow and the sound of your own heartbeat oddly loud in your own ears. That same silence has been sitting quietly underneath every single story we have told since. You know so much more about that scene now than you did when we first stood inside it together. You know that scene was not a one-time event, but something this planet has quietly repeated at least 8 separate times over the past 800,000 years. A rhythm so patient and so exact that it took a genius working from inside a prison cell to even begin describing it properly. You know that rhythm is written into 3 slow invisible wobbles, in the way Earth leans, spins and travels around. This sun wobbles so gentle that not one of them on its own has ever been strong enough to fully explain why the coldest of those cycles behaves the way it actually does. You know that mystery is still not entirely solved more than 50 years after the first scientist brave enough to point it out, and you know that even that opening scene, as vast and as cold as it felt when we first stepped into it together, was not actually the coldest, strangest chapter this planet has ever lived through. Somewhere far deeper in time, 700 million years before any of this ice may have reached all the way to the equator, swallowing the entire globe whole for millions of years, at a scale of cold so extreme it makes even a 2-mile thick ice sheet over Chicago look almost cozy by comparison. You know that a lonely, stubborn Serbian mathematician calculated all of this by hand in a library in Budapest, while an entire war tore through the world outside the window, and that he died decades before anyone finally proved him right, using ice pulled from the single, coldest, most punishing place on the surface of this planet. You know that inside that icy scientists found something close to a miracle, hiding in plain sight, actual pockets of ancient air, breathed by nobody, touched by nothing, sitting patiently in the dark for 100,000 years, waiting only to finally be asked a question. You know that entire countries once existed where there is only open ocean today, that people walked across land that has not existed for thousands of years, and that at least one small determined group of travellers looked out at open water with absolutely no idea what waited on the other side and decided to find out anyway. You know that a flower of all things first revealed a 1,000-year cold snap, so sudden it may have helped push some of our own ancestors toward inventing farming simply because the wild grain they depended on could no longer be trusted to show up on its own. You know that a wall of ice nearly 2 miles thick once carved out 5 of the largest lakes on an entire continent simply by melting in place, and that a sticky, unremarkable patch of tar in the middle of a modern city once swallowed saber-toothed cats and dire wolves by the thousands, preserving them well enough that you could walk past their skulls in a museum today without a single idea of the story hiding beneath your feet. You know by now exactly how much a certain kind of movie exaggerated the speed of it all, and exactly how much smaller in real square miles the actual ice sheets were compared to the version most of us carry around in our heads. You know too that a great deal of what most of us assume about ice ages turns out to be at least a little bit wrong. No instant flash freezing, no single frozen planet except for one truly strange stretch of deep time so extreme it makes everything else in this story look almost gentle by comparison. Not even one single ice age, but at least 5 scattered across 4 billion years of this planet, quietly changing its mind about how it wants to run. And you know, maybe strangest of all, that this story never actually finished. That the ice sheets sitting on Greenland and Antarctica right now tonight while you listen to this technically place all of us inside the exact same ice age this whole documentary has been describing. That human civilization, every single thing you have ever loved, built or believed in, fits inside one brief, unusually generous pause in that ice age's much older, much colder rhythm. A pause that has once or twice before in this planet's history ended considerably faster than anyone standing inside it expected. So here is what I actually think all of this means now that we have reached the end of it together. I think it means we're in a very real and very literal sense living inside borrowed time. Not in a frightening way, in a grateful one, every quiet, ordinary comfort in your life right now, the roof over your head, the food, you did not have to hunt yourself, the fact that you get to lie there worrying about tomorrow instead of simply surviving tonight, exists because you happen to be born during one of the rare, generous exhales of an ancient, patient planet, rather than during one of its long, difficult inhales. It also means every single hardship woven through this story eventually gave way to something. Proof arrived even after decades of ridicule. Vindication arrived even if it arrived far too late for the person who most deserved to see it happen. Warmth returned even after 1,000 years of good reason to doubt it ever would. That particular pattern shows up again and again across this story, often enough that I no longer think it is only a coincidence. I think it means the people we met along the way, the stubborn engineer who refused to let go of a glacier theory, nobody believed the mathematician who kept calculating even when the whole world seemed to think he was wasting his life, the families who built homes from mammoth bone and somehow still found room for music and stories. All of them were doing the exact same thing you and I are doing in our own much smaller ways tonight. Finding warmth, making meaning, building something worth passing on inside conditions none of us ever fully chose or controlled. Somewhere in all of this, I keep coming back to those two men in particular. One who spent his life proving something everyone could eventually see for themselves once he made them look properly. And one who spent his life proving something nobody could see at all, using nothing but mathematics and a stubborn kind of faith that the numbers were not lying to him, even when the whole world told him they were. Neither one of them got to see the full, final shape of the truth they were chasing. I think that is worth remembering the next time something you're working on quietly and patiently seems to be going nowhere at all. You know too that not one piece of this story is actually finished. The 100,000-year riddle is still waiting for its final answer. The exact age of some of humanity's oldest footprints in the Americas is still being argued over this very year by serious people staring at the same layers of dirt and reaching different conclusions. Even the comet that maybe possibly helped trigger that 1,000-year freeze is still being debated, using ocean sediment nobody had even examined until quite recently. Science, it turns out, rarely hands you a finished book. It hands you the current best draft and trusts you to understand that somebody somewhere is still quietly working on the next chapter. And I think it means the ice itself, if it is fair to speak of something so old and so patient as though it had a personality at all, was never really the villain of this story. It buried continents, yes. It erased entire ecosystems, reshaped every coastline on the planet, and forced our ancestors into some of the hardest, most desperate chapters of the human story. But it also carved the Great Lakes. It shaped the very land you are lying on right now, wherever in the world that happens to be. It kept faithfully, patiently, without a single day off in 800,000 years, the only complete record we have of this planet's own memory, waiting quietly in the dark for someone patient enough to finally come and understand it. It gave hunter-gatherers in a drought-stricken corner of the Middle East a reason to plant their first deliberate seeds, setting an entire chain of events in motion that eventually gave you the bread on your table whenever you last had some. It opened and then closed land bridges precisely when different groups of humans needed them, opened or closed, spreading a single species into nearly every corner of the globe, from frozen tundra to tropical rainforest to islands nobody could even see from the mainland. The ice was never trying to hurt anyone. It was just keeping time the only way it knew how long before we existed to notice, and it will likely keep right on keeping time long after every single one of us is gone. I find something strangely peaceful in that more than sad. There's a very old rhythm running underneath your entire life tonight, older than language, older than agriculture, older than every civilization that has ever risen or fallen, and it does not need you to understand it or worry about it or do anything at all in order to keep gently turning. A single human life, even a long full one, barely registers against a rhythm that's slow. And somehow, against every reasonable expectation, that same rhythm still managed to produce you right here, right now, listening to a stranger's voice describe mammoths and boulders and frozen air in the dark. Out of 2.5 million years of ice advancing and retreating this exact moment, you tonight still happened. I do not think that is nothing. So maybe for tonight that is enough to simply let it turn. Let your shoulders drop if they have not already. Let your breathing slow down the way it naturally wants to. Feel the weight of the blanket over you if you have one. Feel the small, steady rhythm of your own breath moving in and out, patient and unhurried, not so different in its own tiny way from the 3 great rhythms we spent this entire night discussing together. You do not need to solve anything else tonight. You do not need to remember every date, every name, every number. The ice does not test you on any of it. It only ever asks to be noticed once by someone willing to sit quietly and pay attention, and you have already done that simply by staying with me this long. Somewhere out past your window, whether you can feel it or not, the planet is still leaning still, wobbling, still tracing the same 3 patient circles. It has been tracing since long before the first human ever looked up and wondered why the seasons changed. It was turning before you were born, and it will keep turning while you sleep without needing a single bit of help from you to do it. You do not have to hold on to anything else tonight. Not the mammoths, not the boulders, not the ice cores, not the flooded lands or the vanished continents. Just let the story settle, the way snow settles quietly, one soft layer at a time, until it is simply part of the ground beneath you. Thank you for spending this long, quiet stretch of time with me tonight. I mean that sincerely. Stories like this only get to exist because people like you are willing to lie back, close your eyes, and actually listen all the way to the end, and that is not something I take for granted, not for one single episode. If some part of this journey stayed with you, the flower that named 1,000 years of cold, the boulder sitting in the wrong country, the prisoner doing mathematics by candlelight, I would love to hear which piece it was whenever you get the chance to tell me. Every quiet corner of the past has a story like this one hiding inside it, patiently waiting for somebody to slow down long enough to notice. And there are a great many more of those corners left for us to wander into together. So rest easy tonight, and whenever you're ready to return, there will be another one waiting. Another forgotten mystery, another stubborn scientist, another vanished world quietly holding its breath until somebody finally comes looking for it. Sleep well. I will see you next time.